Appreciation and gratitude.
Thank you very much, ma'am. It is my honor to introduce an exceptional leader and visionary in the field of quantum computing, education and technology, Dr. Jayakumar Vaithiyashankar. Dr. Vaithiyashankar is the founder and chief executive officer of Anuthantra Private Limited, a company dedicated to advancing quantum technology, training and making complex quantum concepts accessible to learners and professionals alike. He is also an IBM quantum educator and an IBM Qiskit advocate mentor roles in which he champions global quantum literacy and community building. With over 15 years of experience in research, higher education and technical training, Dr. Vaithiyashankar has been instrumental in nurturing the next generation of quantum thinkers. He holds certifications including IBM Certified Associate Developer in Quantum Computation using Qiskit, and he actively participates in international academic forums including IEEE Quantum Standard initiatives. Dr. Vaithiyashankar has published numerous research papers, reviewed technical papers for IEEE quantum conferences, and served as SWAYAM NPTEL instructor for programs under AICTE and DST, including India's first undergraduate minor in quantum technologies. Beyond research and leadership, he is committed educator, having delivered over 100 quantum programs ranging from faculty development workshops to certification training across India, USA, Russia, and Armenia. His passion for quantum computing has inspired professionals and students alike, creating pathway for innovations and research in this cutting-edge field. Please join me in welcoming Dr. Jayakumar Vaithiyashankar.
One more.
You have to press and clip it.
Okay. That is why we don't know.
Disconnect this also. So this is a pointer and changing.
Okay, nice. I didn't clip for him back. Thank you.
Need a charging port.
Right now it is full. If it is needed, I'll ask. Hello. Am I audible? Okay. Good morning to all. I am Jayakumar. I am coming from E-Road. I completed my diploma, UG, PG, PhD in IT. I am very new to quantum computing, just like you. So before 5 years, I started to learn quantum on my own. Okay, so if you feel quantum is very difficult for you, don't worry. Everyone will feel difficulty, including scientists, including Nobel laureates. right? If you feel difficulty, you are par with scientist, okay? So I'll give a glance about how I started my quantum career. So before 5 years or 6 years, I started to learn quantum computing as an IBM educator, okay? So the best way to learn anything is to teach others. So I have around 12 years of teaching experience in various colleges and university. I did my full-time PhD in Malaysia under Malaysian government scholarship. So I keep on teaching. So teaching became my passion. So I took the very good job to teach quantum for students. So I created a curriculum, I uploaded it in a website, and they called for interview. If you are able to clear that interview, they will award this honorary post, IBM Quantum Educator. So once you become IBM Quantum Educator, okay, you are able to know all this stuff. So each and every year, IBM is releasing challenges, open source challenges. So if you have pen and paper, you can note down. So each and every year, IBM releasing open source challenges. So anybody above 18 years, they are able to enroll. So in these challenges, they will give industry focused problem. What are the industry, they are doing research, they are focusing on particular problem. They will give that problem statement in these challenges. Along with that problem statement, they will give tutorial. Okay, so side by side you are able to learn how to solve that problem. They will guide you. They have platform like Discord and Slack. So it is almost like combination of Gmail and Facebook, LinkedIn, everything is integrated. So very easy to converse. So if you are raising one question, so multiple people can answer for the same question. They won't directly give answer for that question. Indirectly they will give clue. So this is very good way to learn something in foundational level. So once you clear these challenges, they will give digital batch like this. More digital batch you have, more industry will recognize you. Okay. So this is the first step you can take. The second step you can go for summer school. So each and every year IBM releasing open source summer school. So which will happen for 2 weeks online. So they will conduct according to the US timeline, but they will record the video, they will upload in the server. Okay, you can watch that video within that day or next day. You need to solve little problems. Okay, programmatical challenges. So everything is built upon Python. So if you know Python, it is very easy to crack. Even school students will crack this summer school, right? So if you calculate monetarily the summer school cost, it will cost 1.5 lakh to 2 lakh, but they are giving free of charge. So whenever company is giving free of charge, utilize it before they are charging for it. Okay. So if you complete summer school,
usually in which month?
I forget, sir. Maybe in June, I think so. I'll check and tell you. I have mine. Let me check. No issue, no issue. Okay, hello. Now better. So without mic also I am able to talk. Yeah, okay. So once you completed summer school, you can go for certification. Okay. So Google is there, Microsoft is there, Amazon is there, so many big companies are there, but only IBM is offering industry level certification. So this certification cost 10,000 rupees, nearly about $100. So remaining everything is free of cost. Only the certification cost 10,000 rupees. Okay. So I appeared this certification along with my student before 5 years. Okay. This certification requires 73% to get pass. I got 72, failed by 1 mark. My student got 85%. So if you are teaching for your students, definitely students will beat you. Okay. So you cannot beat them, because if you want to study quantum, you need to invest lot of time. It is not possible. It is against your workload and curriculum. But if students want to learn, they will bunk class, they will take 1 month time, they will study for themselves. Okay. Even though if you are teaching for your students, they will shine better than you. So who are having time to study quantum, they are able to understand quantum, they are able to get fundamentals. So this is the basic. The primary thing, you need to dedicate time, 1 or 2 hours. So without studying quantum, you should not sleep. Otherwise you cannot clear this certification. The first time I failed with 1%. Okay, after 3 months I retook that exam. This time worse than the first. I got only 65. The third time I took the exam. In between, middle of the exam, internet went off. So next day morning I took the exam. I cleared that exam. So if you want to learn quantum, you should have never give up attitude, persistence and consistency. So if I teach quantum for 100 students, okay, after 3 months, only 5 will stay. After 6 months, only 2 will stay. After 1 year, 1 will stay. So this is the ratio, success ratio in quantum, right? So once you completed this certification within India, you can expect 2 lakh per month, minimum guarantee. So near to your campus, IBM office is there. They have quantum head office. Okay, they are hiring people from UG level and PG level. PG level is preferable. So if they clear this certification, definitely they will get placed in IBM quantum core team, right? So once you have this certification, you have 3 years of experience. If you know Python, if you know this Qiskit, if you know GitHub, okay, if you go for US, the starting package is 12 lakh per month. 12 lakh per month. 12 to 15 you are able to get within 3 years of experience. Even though not IIT topmost graduate, they will get this much of a salary in their first attempt, right? So once you clear this certification, you can look for IBM Qiskit advocate. So this is the next level. Okay, there are 2 conditions to become IBM quantum advocate. The first condition is you need to clear this certification. The second condition is you need to do 2 contribution, open source contribution. If you are very good at designing, you can design a brochure, you can promote this technology. If you are very good at coding, you can code and you can publish in GitHub, you are able to create awareness. If you are very good at composing music, you can compose a song to create awareness about this technology. So whatever the skill set you have, you are able to demonstrate to create awareness and promotion. If you do so, document it, apply with your certification, they will recognize you. So once you become Qiskit advocate, you will become core part of IBM quantum team. So they will give beta software for you. You can use that software. You can give feedback to the team. Okay, you are not only the developer and also you also contributing for the software, right? So this is one good thing. The next good thing is, if there is any conference happening in UK, US, Japan, they will give flight ticket for you. They will take care of your accommodation, each and everything for you, including visa. Okay, so this is one good thing. So once you become Qiskit advocate, you can look for internship. You can look for internship. So normally 3 months they will give internship. If your project is too good, they will extend up to 6 months. They will extend up to 6 months, right? So researchers and scientists across the globe, they will list out some problem statement. If you are interested in their problem statement, you can pair with them. Otherwise, if you have interesting problem, you can propose them. If your problem statement is attractive to their domain, they will come forward to you. So it is bilateral. So most of the time what happening in the companies, they will give problem statement, you need to work for them. It is not like that. If you have really interesting problem, they will come to you, they will pair with you. So once you have internship, once you completed internship, you can go for any software company, not only IBM. Even Google is hiring, Microsoft is hiring. So these are the good things once you have certification. Once you completed internship, you can act like a mentor. So this is eligible for only faculties and professionals who have minimum 5 years of experience. So they can teach students, they can mentor students, they can do projects along with the researchers and scientists. So I guided 2 students from US. They are first year engineering graduates. One student took major in maths, one student took major in physics. They published 2 SCI paper within 3 months of projects. Okay, I don't know what is their problem statement. I guided technically, programmatically, how to document, how to manage all this stuff. They did everything. So sometimes you need to guide students, you need to do some projects. You cannot find right students. You cannot find motivated students. Until they are motivated by themselves, you cannot keep them. Right? So this is the good platform where you can get very bright students across the globe. They will approach you. Right? So once you completed this, you can look for free courses. So all these courses are free. I will give that website for you. So maybe after this session, I will go to that link. I will show each and everything for you. Whether Wi-Fi is there, sir? Wi-Fi? Very good, sir. Yes. First time without any passwords, okay, without any hindrance, just able to log in. Very good. So I can note down this website. If you give IBM quantum platform, you will get this launch page. So top right you can see sign in page. So if you want to create account in IBM quantum platform, nowadays they are requiring credit card. So if you have credit card, if you have willingness, try to create an account. Sometimes they will charge you. So be careful about using credit card.
Not sometimes, sir, they are already charging.
No, sir, not every time, sir. For first time they will charge for checking. If you are using their resource beyond their limitation, then they will charge. Even though they charge 1 or 2 rupees, they will return back. So this is how dashboard look like. So each and every month they will give 10 minutes access time for you. Maybe I will zoom if it is not visible. Now it is visible. So each and every month 10 minutes you are able to access real quantum system. Okay, so if you want to go for commercial purpose, they will charge 9,000 rupees per minute. So imagine if they are giving 10 minutes, it means they are giving 90,000 rupees resource free of cost for your research, for your learning purpose. So if you calculate, credit card charging is justifiable. So if you go top left, you can see learning tab. Downside, you can see learning tab. So click learning tab and you can see multiple courses. So view all courses, click view all courses. So this is what I mentioned in slide. Course 1, Basics of Quantum Information. Course 2, Fundamentals of Quantum Algorithm. Course 3, General Formulation of Quantum Information. Course 4, Foundation of Quantum Error Correction. So if you come down, you can see different kind of courses. Suppose if you want to implement at production level, you can go for quantum computing in practice. Okay, each and every course have some connectivity. So without doing course 1, you cannot understand remaining thing. Okay, so it is preferable complete course 1, course 2 at least, then go for advanced level topics. So course 1, course 2 are mandatory. Most of the time people will ask me whether I can learn quantum machine learning. You can learn quantum machine learning only after learning course 1 and course 2. So without learning course 1 and course 2, directly if you are jumping into quantum machine learning, it is trying to learn swimming in middle of a ocean. So you cannot understand each and everything in that quantum machine learning, not even the first 2 paragraphs. So that much difficult. So complete the basics, then go for higher level topics. And it will take different time level. For students, it will take 1 or 2 months to complete first 2 courses. For faculty, definitely it will take 4 or 5 months. Okay. So if you come down, you can see quantum chemistry. So this is the real scenario why they went for quantum computing. You cannot simulate a chemical reaction in world powerful supercomputer, but you are able to simulate chemical reaction in quantum computer. Okay, only for that reason they went for quantum computer in initial days. So if you take all industries across the globe, chemical industry dominates 60 to 70%, not CS and IT. So take all the products what we are using, definitely it has some raw source from chemical industry. Suppose if you are looking from business background, if you are friends in MBA, they can go for Quantum Business Foundation. So this is very easiest course listed across this web page. Okay, so you can understand this course within 2 or 3 days. You are able to complete and you are able to get digital badge and a certification from IBM. So each and every course have certification from IBM and also have digital badge. Try to collect all this stuff. If you are interested in cryptography, you can go for. If you are interested in cryptography, you can go for quantum safe cryptography. So click the first one, Basics of Quantum Information. Basics of Quantum Information. So it contains 4 modules: single system, multiple system, quantum circuit. Hello. This course contains 4 modules: single system, multiple system, quantum circuits, entanglement in action. Okay, so we will go for the first lesson, single system. you have content like this, you have YouTube video. So this course is taught by Professor John Waters. He is teaching quantum in Canada for past 35 years. Okay, this video will go for 1 hour or 1.5 hours. If you are watching for first time, definitely you cannot understand each and every word in this video. Okay, whenever you have doubt, if you don't know particular terminology, pause that video, go for Google, ChatGPT, some books, okay, do some research, come back to video. So you need to watch quantum video like pause and play, pause and play, pause and play. You cannot watch the entire video in a single shot, you will fed up. So instead of getting motivated, you will get demotivated if you watch this video. Because he want to give all information he collected in 35 years of experience. That is the problem. Okay, we are not prepared to that level. So the second way, you can download slides. You can download slides, you can take printout, then you can study. So it is always advisable to read printed format for quantum, because it contains lot of mathematics. You need to flip pages back and forth. Okay, so it is advisable to take printout then study, right? So if you go for next topics, it contains lot of mathematics, basic mathematics, but lot of mathematics. So what you do, right click this page, click print, convert as PDF, take printout. So do like this. So if you completed all these 4 modules, finally you can go for exam. So this exam is free of cost. Only the certification cost 10,000 rupees. Remaining all these courses are free of cost and you can take multiple times. So this exam contains 20 questions. Out of 20, you need to answer correctly for 16. Okay, definitely you can use ChatGPT, Microsoft Copilot, Google Gemini. You will get wrong answers. Okay, so this is very good checkpoint for your students if they want to understand quantum, because all these LLM have little knowledge about quantum, little resource about quantum. That is good thing. So this is the image. I got inspired. I want to study quantum. Google released a video called Quantum Supremacy. So in 2018 or 19, they released this video. So what they claimed, they took very hard computer science problem. They tried to solve in world powerful supercomputer. Okay, the problem is very hard, NP hard kind of classification. Okay, that problem will take 10,000 years to solve in supercomputer, world powerful supercomputer. They put the same problem in this quantum computer and they got results within 300 seconds, less than 4 minutes. Imagine a problem will take nearly 10,000 years, now came down to just 4 minutes. So that is the potential of quantum computer. So if you are looking at this image, it will look like a golden chandelier. Okay, so made up of gold, copper, mercury, whichever material have superconducting property, they will use those material to construct this machine. It will not look like a computer, it will look like a machine, right? So you can look that red color shield, that shield will cover this entire computer. Okay, so inside this computer the temperature will go minus 273 degrees Celsius, near absolute zero. Okay, so the same technology they used in rocket, cryogenic engine, they use the same technology in quantum computer. So this is one type of quantum computer we have. Like this we have 1000 different types of architecture in quantum computer. In classical it is not possible. In classical what architecture we are using? Sorry about this tone, most frequently I am taking for students. What architecture we are using in classical computer? Harvard, okay. Hardware architecture, I am asking the name of that architecture. No, sir, no. Who handled computer architecture? Von Neumann architecture. Okay, in von Neumann architecture, what we had? We have several components. One component will store, it will compute, it will forward. Between all these components, data will get transferred, it will get computed, it will move forward. Store forward, store forward, store forward. Okay, the same architecture we are using for our laptop, our CPU, supercomputer, mobile, nothing is changed. So if you took any electronic circuit, two things will happen. Either data will get stored, it is computed, it is forwarded to next component. Okay, but this is very fundamentally different. You cannot store data in quantum computer, it will stay for milliseconds. So quantum computer is not efficient to store data, not efficient to store big data. It will only compute the complex task. Okay, whichever task have computational intensity, we are only focusing those problems, not all problems. Okay, only few problems are suitable for quantum computer, not all problems. So whichever is impossible by your classical system, we are try to figure out using quantum.
Then what is the big limitation of this architecture?
A few problems we are not able to solve using classical computer, even supercomputer. So only those problems we are focusing on. It is not limitation. Only for particular scenario we are choosing for quantum computer. Take an example of destroying a target. Okay, you are launching a missile. So for that, missile is justifiable. Okay, to kill a person, if you are putting a rocket launch, that is not justifiable. So likewise, so depends upon your challenge, depends upon your problem, you are choosing your computation.
Means it is utilized only for the
Few things, not for all. So quantum is not for all kind of difficult problem, only few particular kind of problem. Okay, so you can compare like a donkey and an elephant. Okay, you will put whatever the weight carried by a donkey, but if you want to carry by an elephant, the weight should be enormous. For a royal elephant, you need to put that much of big wood or big task in same scenario. So this is the architecture of quantum computer. This is superconducting quantum computer. One architecture, you can see so much of wires. All these wires will carry microwave pulses. So downside you have quantum processor. So downside you have quantum processor. So all this signal will communicate with your processor. It will get computed and the result will be sent back by microwave pulses. So finally it is covered. Entire your quantum computer is covered by this shield. Okay, this shield is hanging from this framework. So if you look at this framework from four sides, it is hanging like a fruit. Okay, it is isolated from its surroundings. If you are walking, if you are talking, your body temperature, everything will impact your quantum system, your quantum computation. That is why we separated from outside environment. Downside also you can see that square. It have springs, vibrations. It won't impact the next tiles.
So this processor operating -273 degree.
Yes ma'am, yes ma'am.
So it is freezer resistant.
This is one type of architecture. In room temperature also you have quantum computer using photonics. I will cover that. So you are using your computer or laptop and you are converting any quantum circuit. So all this circuit is transmitted through these wires, converted into microwave pulses. It will go for your quantum processor and it will get back result to your laptop. So quantum computer doesn't have monitor or keyboard. Okay, we are using classical computer to communicate with quantum computer. So this is the investment scenario across the globe. So if you look at US invested 1.2 billion. So China invested $15 billion. India invested $1 billion. So investment of India is nearly 6,000 crores. Very less when compared to China. So China definitely will become the world leader in quantum. Okay, that is the biggest threat we have. So this is a NGO, qubit by qubit. You can note down this website, qubit cross qubit. So they are teaching quantum for school students in US. They are teaching quantum for school students in US. They started to focus from 8th standard. So students who know fundamental trigonometry, algebra, they are able to understand quantum. They break down up to their level. So what are the concepts graspable by school students, they are teaching in that way. And the cost of this training is nearly 1.5 lakh. Okay, so all these sponsors, IBM, Google, Microsoft, they will sponsor for this project. So across the globe, any students can go for this program, they are able to apply. From India, we trained 3 schools from Tamil Nadu. So all these from rural background, those students are able to complete this course with 95% grade. Okay, they teach for 8 months. So Saturday, Sunday, they need to dedicate 1 hour. They will teach according to US timeline, but video is recorded, uploaded in the server. Along with the students, school teacher able to enroll for this course also. So teacher will learn that course. So during class time, they will project in the projector. Then they will co-discuss with students. So it is a mutual understanding, right? So if you are doing in this way, definitely your school students are able to crack this course. Free, sir. Free. That is why these many sponsors. Qubit by qubit. Qubit by qubit. It is an NGO funded by NSF, National Science Foundation, a US government body. Weekly 1 or 2 hours, ma'am. They will take theory part, they will take 1 hour Python part, they will give assignment. Our students are able to complete even from rural background. That is the beauty. So initially I thought students not able to understand their accent, but able to do all this stuff. So based upon this, US government created National Quantum Initiative. They want to be a dominant world leader in this domain. They created the entire framework for this. So like copycat, India also did National Quantum Mission, inspired from that framework. Okay, India allocated 6,000 crores. So initially they allocated 8,000 crores. Within 6 months they got 2,000 crores. Now we got 6,000 crores, which is very, very minimal. We cannot do anything within these 6,000 crores. So our aim is to create 52,000 physical qubits. So within 2030. Okay. So now IBM have nearly 1,024 qubits. In India, we have very, very limited resource. I'll show you. So India's National Quantum Mission spread out into 4 important domains: quantum computing, quantum communication, quantum sensing and metrology, quantum materials and devices. So if you had quantum is not for CS and IT. CS and IT have very fractional part. Remaining department, remaining domain have major contribution. So if you are from ECE, if you are from EEE, if you are from mechanical, physics, chemistry, you have more contribution when compared to CS and IT. So this is the thematic hub. I will share this slide with you. So each and every hub have so many technical groups. All these technical groups have much more team like spikes and spokes. So this is the geographical location of all these quantum hubs. So IIT Delhi stands for quantum materials. IIT Bombay stands for quantum sensing and metrology. IIC Bangalore stands for quantum computing. IIT Madras stands for quantum communication. Okay. IIT Madras stands for quantum communication. So they are major players. Under these major hubs, so many institutes are joined together to accomplish mission. IISc Bangalore, ma'am. IIT Madras. IIT Madras. So we have only one IIC in India, and we have so many ISER, okay, and also we have NISER in Bhubaneswar. So before 4 months or 5 months, I know every one of you know about Honorable Chief Minister Chandrababu Naidu. He made a MOU with IBM, TCS and L&T. He allocated 4,000 crores for Quantum Valley in Amaravati. So it is supposed to start from January 2026, but little hiccups, maybe they will start from March, I think so, in operational mode. Okay, they allocated 4,000 crores. So Indian government allocated 6,000 crores, but a small state allocated 4,000 crores. So based upon that, Microsoft also invested 1,000 crores. So Andhra Pradesh itself, they have 5,000 crores investment in quantum domain. So Karnataka also invested 1,000 crores. So this is one facility in ISER Pune. Okay, they created NMR, nuclear magnetic resonance. Using that, you are able to build a quantum computer. So this is that facility. So whatever you are looking at this cylinder, it is looking like a giant magnet. Okay, so this magnet is 10,000 times powerful than Earth's magnetic field. Okay, if you are bringing your laptop or cell phone near to this, okay, it will permanently damage your device. This cylinder, it will act like a giant magnet. Okay, so it is 10,000 times powerful than Earth's magnetic field. Earth's magnetic field. So nearly they invested 400 crores for this setup. They created until 38 qubit. So this is the maximum capacity we have in India, 38 qubit, but technology is different, using NMR.
Then how will they operate? The human body cannot do it.
No sir, it won't affect us. Normally magnetic field won't affect us. That is a good thing. Only for devices.
But the blood is having the iron content.
People are working, sir. They are working for 15-20 years. They don't have any symptoms. As far as I know.
Any no bad effects kind of?
No, sir, no.
Any application of
Different application, ma'am. Each and every quantum architecture have different rules. Maybe for quantum simulation, ma'am, chemical simulation, they will use. You can use for computation also. Whatever I show, you can use for computation. You can go for chemical reaction also. So technically, I don't know how they are using. I have the glimpse. Okay. So this is lab at IIC Bangalore. So if you are located in Bangalore, you are blessed. So many facility within Bangalore. Okay, they created using quantum optics. So this quantum computer will operate in room temperature. Okay, so it is like tabletop model. Okay, but it costs 3 crores. Not about the cost. If you want to calibrate this lab, it will require 3 years. So by millimeter, they will calibrate all these components. A different purpose. So they have cryogenic quantum lab also in IIC Bangalore. Under few circumstances, they will open this lab. So this is the processor they built in-house. So this have capacity about 4 qubits. Ingenious. Okay, made in India. But remaining components they imported from UK. Only the processor they built, remaining they imported from UK. So this is one more lab in ISER Bhopal in Madhya Pradesh. Okay, they have diamond computing quantum lab. Okay, so diamond have nitrogen vacancy. It is considered like impurities. So this impurity will help you to do quantum computation.
Sir, can you just explain how you are making it? Because when you are speaking about the diamond,
Yes, sir.
it has got its own chemical properties also. Like it has got carbon is there, and then we are having the other chemical composition will also be present. But how you are going to extract only the specific nitrogen for the computation here? And
So-
the chemical composition also will vary. These are the chemical composition.
They have nitrogen vacancy. Due to that vacancy, you can do computation within the diamond crystals, sir. So what they are doing, they are keeping some samples. Okay, so the light is flashed over there and it will penetrate to the diamond and it will go through this sample material. By looking at that spectrograph, they are able to analyze that property.
So are the diamonds which are being used with the regular normal persons that diamonds are using, or the diamonds which are used for the lab is totally different?
Totally different. The impurities should be there. That impurities should be suitable for computation purpose.
So for those diamonds, does India have those kind of diamonds?
We have, sir, and we are producing a Surat also, Gujarat. So in IIT Bombay, they have special lab for this. They are focusing on NV diamonds.
So, but how you are going to handle the chemical composition? The composition will be varying, right?
I don't know exactly, sir. I don't know exactly. So you can go for Iser Bhopal web page. They have a proper web page and team. They posted each and every detail for you. So if you are really interested in this technology. So this is only have 1 qubit. So each and every quantum computer architecture have different capacity. So even though they have 1 qubit, they have some purpose. So they are conducting 1 week workshop, NPTEL workshop. If you are interested, each and every year look for this announcement. They are offering 1 week offline workshop. Okay, handled by Professor Ankur Jain. He completed postdoc from US in quantum information, and he completed PhD from IIC Bengaluru. So 1 week you can enjoy that luxury. Okay, you can stay over there without thinking about your institution, workload, family. You can stay over there. Which month I don't know, ma'am. You just keep on looking in LinkedIn page, they will announce you. NPTEL workshop. In Swayam also you are able to get all these details. So this is the facility in IIT Kanpur. They have quantum optics lab and entanglement lab. So if you want to know the professor name, Anand Kumar Jha. Okay, so if you have chance to visit this institute, try to visit quantum lab also. So before visiting, mail them, mention the purpose. Okay, sometimes they will agree, they will allow you. So these are their lab setups. And they invited for NPTEL recording. I stayed for 1 month, recorded video. So this is the national initiative. So all India level, 3 IIT and 4 NIT collaborating together to provide national level FDP. Okay, so they conducted 8 series. Our team participating in each and every series. And this is Q Karyashala. In IIC Bengaluru, each and every year, they are conducting quantum workshop sponsored by Karnataka state government. They will give preference for Karnataka faculty, students, research scholars. So first preference given for Karnataka people. So past 3 years I am continuously attending. So this is last week of June, or 3rd week or last week of June, you can notice. So India want to make their position, they want to become a dominant leader in quantum, at least they don't want to give up. So they created undergraduate course. Initially they thought to create master program. Nowadays students are not interested to enroll in masters. They went straight away for undergraduate program. So DST along with AICTE will give minor degree in quantum, irrespective of institutions. So your college students able to get a minor degree from AICTE. So this is the curriculum. If you go for AICTE, you can Google like this. Model curriculum for minor degree for UG degree course in quantum technology. We will have 14 or 15 pages of curriculum.
So this curriculum will be an online course?
Online, sir. In NPTEL they will provide. I will tell you. So these are the credit structures and these are the courses. So totally 11 courses are there, 13 credits are there. If any faculty able to complete 6 FDP, what I mentioned before, they able to get PG diploma from AICTE in quantum technology. If any student is able to complete 6 NPTEL course, okay, they are able to get minor degree from AICTE in quantum. So this will help them to get masters in abroad or within India. They will give preference. So in future, even though they will take from UG level. So nowadays they are looking for PG, they are not hiring UG level. So this is our startup name. Before 1.5 years we started Anuthantra. Anu means subatomic particle, Tantra means technique. So we are dealing with quantum technology, we aptly named Anuthantra. So these are our founders. One of the co-founder is from IIIT Dharwad. So if you are near to IIIT Dharwad, contact Mr. Ashwath Babu. And this is one tool built by CDAC, Quniverse. Okay, so in future they will recruit, if anybody know this tool, and they are giving certification also. The certification cost 1,000 rupees. They will announce in their LinkedIn web page. So try to follow their LinkedIn web page, CDAC Bangalore or CDAC India. Okay, so each and every year they are conducting certification course. So once you completed that certification, so much of openings will happen in future. ISRO, DRDO, CDAC, CDOT, all these institutes going to hire in quantum domain. So this is one tool developed by CDAC and ISC Bangalore called QSIM. So if you have interest, just note down. Quniverse. You need to request access. You need to request them, you need to mention your mail ID, what is the purpose. After reviewing your application, they will give access for you. So that's all about introduction.
Are you offering any certification course?
Planning, sir. Right now we don't have time. We are visiting so many places and we are restricting also. We are focusing on building product. So if you go for pitching, they will ask hardware product. Not like this training software. They are looking for hardware. That is the problem. So teaching quantum, understanding quantum is very difficult. So we need to take the right material. So this material is created by Miss Geetanjali Venkatraman, working in UK as a illustrator at ThoughtWorks. Okay. So whatever you observe in this slide, everything is handmade. Okay, drawn. Very difficult. It takes 1 year time to create this material. I created an animated PPT out of this PDF. I will share this material with you. So after this session. So each and every part I cropped, I added animation. So students will be able to engage this content. Nowadays, what is the difficulty? You cannot engage students after 30 seconds. They are looking for Instagram reels or YouTube reels. So very challenging period for faculties. Okay. So if you are keep on taking Blackboard or if you are keep on using static PPT, they will get bored. So we'll discuss about Moore's law. What is the meaning of Moore's law?
The number of transistors will double for every 6 years.
Not 6 years, sir.
10 years.
No. 18 months, 2 years. So each and every 2 years, approximately, the computation power will get double. So this is predicted by Jordan Moore, one of the co-founder of Intel in 1965 itself. So such a pioneer, right? So how to increase the computational speed, double the time? We are focusing on transistor. Okay, so transistor, nowadays it contains billions of transistors in a processor. Okay, the challenge is you need to double the number of transistors, but the area remains same. So how to achieve that? The processor area remains same, but the target is double the number of transistors. Yes, ma'am. Already we are embedding.
Reducing channel width.
Reducing?
Channel.
Reducing transistor itself. So if you are reducing transistor size to the half, then you are able to double the number of transistors within the same area. So each and every 2 years, you need to reduce transistor. What about the size? Half of the size. So if you are building transistor 10 nanometer this year, within 2 years you need to reduce 5 nanometer. Very, very engineering challenge is about miniature. But if you are able to do so, the processor becomes cheaper, the processor becomes smaller, and it will become more powerful. So that is why all electronic components have depreciation value. So if you are purchasing laptop, next 2 years, it won't take up 40% of its value, right? So we are able to do so, but this law about to fail. After some point of time, we need to focus on transistors. So look at the transistor. So look at the transistor. Transistor will act like a switch. So normally the size of transistor is 10 nanometer. Okay. So if you are passing power supply, if your transistor in on state, it will allow your electron flow. If your transistor state is off, it won't allow. So you are able to represent your binary data by controlling your flow of electrons. If you design transistor less than 2 nanometer or 3 nanometer, what will happen? If you are designing transistor less than 2 nanometer or 3 nanometer, what will happen? Yes, sir. Nothing wrong. The electron will not flow as per your expectation. Okay, it will behave very widely, very weirdly. You cannot reduce size less than 2 nanometer or 3 nanometer. If you do so, you are hitting nature's fundamental limit. Quantum effects will come into play. So what is the meaning of quantum effect in this context? Quantum tunneling. It means electrons will jump and flow even the switch is off. Imagine we have light. This light is connected to a switch. We are able to control this light by controlling your switch. Okay. If you are switch on, but if your light is not turning up, if you switch off, automatically your light is turned off. How will you feel in middle of your night? Like a ghosty feel, some spirit, okay, which is go beyond your control. So something is taking your control. Okay. So likewise, if you design less than 3 nanometer, the electron will not obey. It will jump 0 to 1, 1 to 0 automatically. If it jumps automatically, it go beyond your control. Data become unstable. You cannot use that device to store and also to compute.
Sir, but also innovation on the quantum tunneling only, sir, for mobile sensors.
Yes, ma'am.
But they have the control on it.
Which one?
The quantum tunneling.
You cannot control.
But the robots, they have also that.
They demonstrated, ma'am, for entanglement. Bells you are talking about, right?
You know, sir, recently they have got the.
No, they explored one of the quantum tunneling property. They are not able to control. They are not able to control.
So this is it because of the potential it's not.
Yes, sir. Potential will. Imagine we have a door. Why we have door in this class or seminar hall? To stop, to control motion of the people. Suppose if there is a magician outside, he do some black magic. Even though the door is locked, he able to penetrate. What is the purpose of having that door? Likewise. So you cannot control your electron after some barrier, after some potential barrier. It will jump. So it is like a magic. So Einstein able to understand this, but not able to recognize this. He disproved, he not able to accept this quantum technology.
Is it uncontrolled electron? Is it quantum? You can say.
After a certain size, sir, you cannot control electron flow. It will jump. We don't know how it is jumping.
So that's what.
There should be somewhere the authors or the researchers might have found out that how the electron jump is happening when they are going with the less than 3 nanometer. Is there any some work which can be referred that how the electron behavior is having?
They cannot able to understand why it is happening, but they observe. For
Saturation level is reached.
yes, ma'am.
Saturation level is reached.
Okay.
It is unable to control.
Unable to control. But the final point, you are not able to control your electron flow. If you understand that much, that is more than enough.
So, but it will have its own velocity also, no, sir? It will have its own velocity and it will be emitting its own radiation.
Yes, sir.
And when it is jumping, it is going to dissipate its own energy,
Okay.
which can be converted to power also.
Okay.
And it is going to create an episodical movement of the electron. And it is going to radiate the power also. How we are going to handle these situations in this case?
I don't know this answer, sir. But the way it behaves in this, very absurd. We cannot understand why it is happening.
So actually, the electrons will leak through the gate outside. In
Okay.
that way, the power is lost. That's how we are not able to control it.
Okay.
That makes happens, right? Yeah.
If you are interested, sir, please go and refer. Definitely it will lead some ideas. Okay. So many quantum terminology phenomena are not discovered yet. So I'll skip these slides. I'll go for important slides. Nearly 160 slides are there. It will take whole semester to cover.
So your slides is enough to teach our students for quantum.
Enough, sir. Introduction. More than enough. So, complexity theory, everything will come. So, if you understand quantum, you can understand better classical things in a better way. So, P versus NP, NP hard, you are able to understand all this stuff. Okay. So what is the meaning of quantum? Quantum came from quantus, a Latin word to depict how great. If you have little modification, you have quantum, which means smallest piece of energy where you are able to measure. So it is a term referred to a measurement, smallest piece of energy. Okay, where you can find smallest piece of energy? Within subatomic level. Okay, so whatever happening within subatomic level, you can use quantum like a prefix. Quantum, quantum orbit, quantum mechanics, quantum phenomena, quantum effects, quantum tunneling means you can understand it is within subatomic level. So quantum mechanics is the best language human ever created to describe nature. If you want to describe nature, if you want to understand nature, so we need to understand quantum mechanics. So quantum mechanics is one of the toughest subject in entire engineering, right? So we will start from classical world, how we perceived our classical world, starting from Isaac Newton. So what is the major contribution about Isaac Newton? Gravitational. So he able to observe the fall of an apple. Okay, apple is falling towards ground or earth because earth is pulling towards it. Whether apple is pulling earth towards it? Yes. whether apple is pulling earth towards it.
That is metaphysics.
Actually, it is pulling each and every object in this universe according to its mass. It will exhibit own gravitational force. Because earth have greater mass, it is pulling easily. Imagine if apple have equal mass to the earth, what happens? Both will revolve across each other. Okay, so compare moon with the earth. Why moon is not colliding with the earth?
Its own force.
Yes, it has own mass, but why it is not colliding? Earth is need to supposed to be grabbed towards it, right?
No, there is an opposite pole which is maintaining that orbit so that the moon is not getting inside the Earth's orbit. There is an equal opposite reaction which is being placed within the moon. Force.
Yes, one interesting stuff. The orbit is not circular, not constant. It is elliptical. So that is why it is able to maintain.
Centrifugal force or centrifugal?
You are from physics, sir.
No, sir, from AC.
Okay, very good, sir. So what Isaac Newton did, he want to understand the gravitational factor. That problem is so intensive, very complex. So he want to explain mathematically. There is no tool in mathematics. Single-handedly he created differential calculus and integral calculus. Okay, so why we are using differential calculus? If we are not able to solve a big problem, you are taking a small part out of it, you are doing first order derivation. Okay, from that small part, even though it is difficult, you go for second order derivation. Once you have a manageable level, what you will do? You will do all this analysis, you will get accurate results, you know where you took from, you do the reverse process using integration. So Isaac Newton is major reason for developing ideas in differentiation and integration. So he is father of modern day physics, modern day mathematics. Okay, because of this he is able to understand the gravitational factor, able to explain acceleration, inertia, leading to velocity, momentum, leading to action reaction. Whatever the law apply for a small apple, equally apply for larger planetary objects. No escape, no bias, not like humans. Nature behaves in equal way. Okay, physics obeys in same way. So this lead to a predictable universe. So science made us to predict each and everything. If you know certain phenomena, if you know how laws works, you can predict, you are able to control. So that is the purpose of science. Now if you compare quantum with classical, everything is different. So whatever we discussed in previous slide, it is totally different from quantum world. Whatever the law you studied in classical physics, it will not work in quantum world. So that is why if you learn more in your career, above 35 or above 40, if you have masters, if you have PhD, you have more difficulty to understand quantum. When compared to students, they will catch up very easily, right? So laws operate differently in classical physics and quantum physics, quantum world. So that is the boundary. Atomic orbit is the boundary. To understand this, we need to go for school level understanding. Particle nature, wave nature. We will take an example for particle nature. We are taking a full bucket of sand and we are pouring it down. Downside we have a slit. Okay, slate. Slate contains 2 holes. So beneath that we are keeping a slate. Okay, we are getting 2 distant piles. Why we are getting 2 distant piles?
Because of the whole body has been made.
Sorry, any students are there? PhD scholar? PhD, you are not just student now. Yes sir, proceed.
So we have got 2 holes which have been made, which are of the different diameter.
Okay.
Because of that, the pile of the sand is totally different, which is getting piled up.
Okay. Why it is falling down?
Because of the gravitational pull.
Very good. Very good. So sand is made up of granular particle. Each and every particle is free to flow, independent. Okay. So because of that, we have experimental setup, we have two holes, because of gravitation it is coming down. So after coming down it will get slanted. More it is pouring, more it will slant away. Right? So if you know your material, if you know your setup, if you know how law works, you can be able to reason out why it is happening or how it is happening. If you do the same experiment with the water, so in the bucket you fill water, okay, then you are keeping the same setup, two slits, and you are tapping from left side and it will create ripples. Ripples will go through two slits and it will create interference pattern. So if you know your material, it will behave like a wave. Okay, so this is particle nature, this is wave nature. But if you are doing the same kind of experiment in quantum, you will get very, very unexpected results. So quantum is full of surprise. You cannot predict anything in quantum, okay, after some point of time. So that is why it is very interesting for scientists also. Yes, sir. 5 minutes or 10 minutes? 10 minutes reasonable. So time is 11:50. 10:50. So 11 o'clock or 11:05 we will assemble. 11:05. Yes, ma'am, I will share. Shall we start, sir? So quantum means within subatomic level you frequently encounter randomness. So that is called quantumness. Okay. So within subatomic level, most of the things will happen randomly or random fashion. I'll skip these slides. So there is so much of relationship between light and religion. Okay. So what is the connection between light and religion? Light and religion. Form of God. Light and God. Most of the religion, they associate God with purest form of light. Back side of their head you can see that aura, right? So light is always associated with religion. Why light is associated with God? Why they mention form of a God in the most purest form of light? Superpower? If there is no light, darkness. Okay, so during night time we won't step out. Humans, we won't step out. During daytime only we will do all our activities. Okay, so we have fear. During night time we have fear. If you cannot see your surrounding, you cannot step out. So always light is associated with wisdom and knowledge. If there is light, there is a knowledge, you are able to get the wisdom. Okay, so the word guru is beautifully framed. Gu means the darkness. Ru is a person who can remove the darkness. Okay, so if you want to understand quantum, it will lead to various fields. It will lead to religion, philosophy and also science. Most of these scientific experiments in school days you can recall from school physics. School physics always start from light experiment, using prism, using lens. Okay, you are able to control your light, you are able to observe its property. For quantum also, we need to use light. So I am keeping a blackboard, I am keeping a light, and we are setting the same setup, which is called Thomas Young double slit experiment. So in 1800, they created this experiment. If we switch on light, what will happen? Light will travel in 360 degree, like a wave. Okay, because we have two slits, it will diverge and it will reoriginate from two places. Because they have difference in origin, okay, they have conflict. Sometimes it will go along, sometimes it will have conflict, like almost all the religions. Okay, so take Abrahamic religion, Christianity is there, Islam is there. These two religions have few conflicts, few differences. Okay, even though they originated from the same, they have some conflicts. Same go for Hinduism, Jainism, Buddhism, Sikhism, Hinduism. They have little difference. So more and more you understand quantum, more and more you are able to understand religion also, spirituality also, philosophically. So you will get output in this way. You will get output in this way. At some point it will collide, it will create darker band. Some point it will go along, it will amplify. That is why you have continuous output. So somewhere you will get darker band, somewhere you will get lighter band, like a water wave, ripples. So this is due to interference pattern. This is due to interference pattern. Here light behaves like a wave. So if you have little modification, so in the right side, you are adding two detectors. So these detectors will act like doors. At one point of time, one door is open, one door is get closed. If you are doing so, you are able to control the light. So interference won't happen. Okay, if door 1 is open, you will get the upper band. If door 2 is open, you will get the downside band. Only 2 bands will get. So recall the previous example. The first one relate to wave nature. The second one relate to particle nature. Okay. So in concluding, if you are not observing your light behaves like a wave, appears like a wave. Okay. It will spread out like a wave. If you are not observing, if you are not looking, it will appear like a wave. If you try to look your light, it will appear like a particle. Your wave will collapse to a particular point, it will appear like a particle. So this is related to Hinduism, Sikhism and Islam. Okay, if God exists everywhere, like omnipresent, so it behaves like a wave. But if you try to look God at one particular point of time, in one temple, in one ideal, you believe God exists in only that ideal. So which one is true, which one is false?
What is the exact reason, sir? This double split experiment?
This one, ma'am,
That particle, where
if you able to divide, okay, it will get a continuous output. If you are controlling one of the slit, you don't have interference. If there is no conflict, there is no interference. Right? If you are not observing your light, if you are not controlling, it will behave like a wave. If you try to control, if you try to observe, okay, it will collapse, it will appear like a particle. So, what,
why
ma'am?
it is so, sir? When we observe it, then only it is behave like a particle.
Yes.
How it comes to know or why it behaves?
Imagine your light waves are traveling here. If you close this, if you open this, what happens? Light will only navigate over here like a torchlight. So if you have two torchlight simultaneously, if you are switching on, what happens? Interference will happen. So if you look at micro level, you will have a darker band and lighter band pattern, like a wave. So waves will overlap, right? So that is the interference pattern. So if you are not separating your God, exists everywhere, that is Advaitam. If you are creating a difference between a creator and a creation, it will lead to Dvaitam. So all these principles related to physics, related to philosophy also. Now we are changing our source material. So instead of light, we are using an electron gun. So here what we are doing, we are generating electron one by one, like a cricket ball, like a particle. So sometimes it will go to up slit, sometimes it will go to down slit. And what is the output you expected for a particle? 2 bands. But what we got as the output? Continuous wave. Why it is so? Recall the previous experiment.
Just the continuous behavior because the slit is being divided there.
But we are generating particles, sir. We are not generating wave. We are supposed to get particle output, but we got wave output. Interference. But particle, how it will generate interference? So it will go through up slit sometimes. It will go to down slit sometimes.
The velocity of the particles is not fixed.
Here there is a twist. It will behave like a wave, also like a particle in a combination. We cannot determine. So that is why quantum is more complex. So what happens? Your particle is generated over here. It can get split. It will go through both slit at the same time. It will combine. Then you will get the output. So this is the duality. You don't know at what point of time it behaves like a wave, it behaves like a particle. Nature itself like a duality. So if you try to understand this experiment using classical physics, you cannot predict. Okay, so this is important line. If you do any quantum experiment, the outcome is nearly impossible to understand nor to explain. So this is very beautiful statement to me. So if you are believing so, you can take PhD project in quantum, you can take master project, Okay, if we try to explain, your examiner cannot understand. Okay, if we try to make them understand, they cannot able to explain. So you will have very much confidence. You can easily defend your PhD thesis. The problem is, each and every time if you do quantum experiment, you cannot predict your output. Output is randomly changing. So it is contrast to classical physics. So classical physics means if you throw a ball, you can predict where it will end. But in quantum, if you throw a ball in quantum world, you cannot predict where it will land. Because everything is involved with randomness. Can you generate a random number using your laptop or CPU? If you are having a C code, C++, Python, Java, are you able to generate a random number?
Yeah, we can generate a random.
Very good, but we cannot be able to generate a random number. Once you write a program, it is a deterministic. It is pre-planned. If it is pre-planned, it is not a random one. So whatever you write a code to generate a random number, it always generates pseudo-random number. So note down this concept. So fundamentally, we are creating pseudo-random number using our laptop. So much of application needs real random number. Okay. So by using code, by using program, we cannot able to generate true random number. Always it is pseudo-random number. But in quantum, you are able to generate true random number. That is the primary difference. Still, most of the crucial applications, cryptography, they require true random numbers. So quantum built upon two principles, superposition and entanglement. You already covered all these topics from previous lecture. Even though if I am taking the same topic, you will have different flavors. So if you start to read quantum, you never got bored. You always got excited. Right? The same topic delivered by different people, you will have different context, different understanding. So superposition means one position over another position at the same time. In simplest terms, suppose if you are looking at your object with your naked eye, you have a vision. If you are having Google or glasses, your vision is imposed by your Google or glass. Over your glass, if you are wearing a 3D glass, you have double imposition about your vision. Okay. So any quantum particle, example photon, electron, ion, neutron, it will spread out like a wave. Whatever you studied in your school chemistry, they will depict electron like a dot. In reality, electron will not appear like a dot, it will appear like a wave packlet. So electron will exist anywhere within that orbit or region. Okay. So it will spread out like a wave. If you want to know its existence, you can take an help of probability. Suppose at this point of time it is not visible. Now also not visible. Okay. Imagine there is a wave. Imagine there is a wave. Okay. At this point of location, 20% of probability. At this point of location, 30% of probability. At this point of location, 50% of probability. So same quantum particle can exist in multiple places with different probability. It is possible. Take an example of myself. Okay, I am giving a lecture over here. I am existing 100%. At the same time, I cannot exist in Delhi. I cannot exist in US. But in quantum world, I can exist in multiple places with different probability. Are you agreeing whether it is possible or not?
They said that it is possible.
It is possible. We are living in parallel universe. Okay, multi-universe. We don't know where you are existing. During your dream, you will exist in somewhere universe. During wake up call, you came to this universe. Okay, you will have different feeling, like Avatar movie, right? A quantum particle, a state of being in multiple location at once, each with different probability. So this is possible. For a quantum particle, it can exist in multiple places, it can exist in multiple probability. So if you want to know your quantum particle superposition, if you want to define, okay, like adding all the waves in water to form a resultant wave, what you supposed to do? You need to add all quantum states to form a superposition. So it is like a biography. If you want to write your biography, you need to know from your beginning. So if you add all those events in your life, you can write a biography. Okay, so your biography is like superposition. It is a combination of all your life states. Same way, if you want to define quantum superposition, you need to add all quantum states to form a superposition. So if it is not clear, don't worry. We'll go with classical example. So defining quantum by using classical is a misguidance, but we don't have any choice. Our brain is evolved to understand classical information, okay, classical physics. Quantum physics is beyond our limitation. So what we are using classical example to understand quantum. This is approximation. This is not accurate sense. Okay, so you can use classical example like tossing a coin. If you toss a coin, what happens? You are creating a superposition between head and tail. So coin contains two phases. It means during the superposition, during the air flip, so 50% of the chance it is being head, 50% of the chance it is being tail. When you can say 100%, it is head or it is facing tail. Allow that coin to freely fall down. After some point of time it will settle down. Then do observation. If you don't have patience, what you can do? You can use your hands to stop that coin. Then you can observe. Okay. So stopping that coin is a measurement operation. Okay. So looking that coin is like observation. So measurement comes first, then observation comes next. If you do measurement for any quantum particle, superposition will get collapsed. So write down this point. So if you do any measurement to a quantum particle, superposition will get collapsing the flip of a coin. Then you can see 100% facing to head or 100% facing a tail. So relate this experiment to Erwin Schrödinger cat. What is about this experiment? Erwin Schrödinger cat. Yeah, alive cat is kept in a box. That is a black box. He cannot see what is inside of that box. So we are keeping a radioactive material. So this radioactive material going to decay. We don't know when it going to decay. It is like a time bomb, but you don't know what is the time it going to be exposed. Once it is exposed, okay, cat will become dead. So two states possible for a cat, alive state and dead state. Inside that box, you don't know what is the state of that cat. When you open that box, what you are doing? You are doing measurement. When you are looking inside that box, you are doing observation. Okay. So if you are not doing observation or measurement, cat exists in superposition. At the same time, cat can be in alive state 50%. Dead state in 50%. Whether it is possible in classical physics. The same person cannot be alive 50%, cannot be dead 50%. Alive means 100% alive, dead means 100% dead. Only in quantum it is possible. So we are increasing complexity. We are taking a cube. Cube contains 6 phases, each phase colored with different color. Okay, so which phase appear front for you? Orange or blue? So which side of this cube face front for you? Orange. I am not added from which angle you are observing, because you are observing from this face. Okay, this angle, orange appears front for you. If you are observing from back side, maybe the blue appears like front for you. So each and every person have their own truth version, perspective, right? So we cannot accept or deny the other person observation, right? So in quantum, if you have 6 phase, 6 equal probability, but when you do a measurement, you will get only 1 possibility. So this is the beauty about quantum. So this is only for 6 phase. Suppose if you have 100 phases, when you do measurement, you will get only 1 possibility, ignoring 99 possibilities. Now you compare this with electron spin. Now you compare with electron spin. Consider electron like a cricket ball. It could spin upwards, it could spin downwards. If it is spinning upwards, you are attaching your data logic to 0. If it is spinning downwards, you are attaching binary data to 1. So sometimes cricket ball can spin diagonally also. It will wobble. During that time, it is in superposition. At the same time, you are able to represent 0 as well as combination of 1. So here quantum comes to the picture. In classical, either you can represent 0, either you can represent 1 at one point of time. But in quantum, you can mix both states. You can represent any value in between them. But when you do measurement, your result converted into classical, either 0 or 1. So in superposition, it is in unconditioned. Okay, when you do measurement, it becomes OR logic. Are you able to get the idea? Whatever the data you have, you need to convert into quantum version, superposition. Superposition have lot of possibility. You can do all computation. After computation, if you do measurement, what happens? All combination collapse together, you get only one possibility, either 0 or 1 in classical binary form. So finally, you will get binary results using quantum computer. So any doubts until this? No means good?
Can you give one more example, the real life scenario for the quantum communication like superposition?
Take an example, ma'am. Not communication, I will tell. If you go for purchase, okay, if you have 4 dresses, if you like all these 4 dresses equally, how will you choose? Based upon your budget. So how much budget you have, you will fix. So once you have clarity upon which parameter you are going to decide, it will get collapsed. So confusion will go away. So superposition is just like confusion. So multiple choice, multiple option, but when you make a decision, it will collapse into 1 or 2 forms. I will come to communication, ma'am. I will do communication. So entanglement. Give an example for entanglement, or what is the meaning of entanglement? Have you heard about entanglement? Any example?
Whatever there is the source, same will be there in the destination also.
Okay. Example, any real-time example?
Like the communication between Mars and Earth.
Okay.
Whatever the message is there in the Mars, same will be there.
So in simple terms, you can say like strong correlation. Under the light laboratory condition, if you are taking 2 photons, 2 electrons, if you are creating strong correlation between them, like doing marriage between them. So relationship between husband and wife, highly correlated, strongly correlated. Whatever happens for husband, it will immediately impact on wife lifestyle. Whatever happens for wife, it will immediately impact on husband's lifestyle. The same correlation you can see between parents and children. So whatever happens for children, it will immediately impact in parents' lifestyle. So all these are examples for entanglement. Taken another example. Whatever happens for you, your mother can sense from distance because you spent 10 months in her womb. So there is a natural phenomena, natural strong connection between you and your mother. Sometimes she will tell you, right? I feel something bad for you, something happening for you. Is it real? She will ask. Same way, relationship between two twins. Whatever happens for one twin, the other twin can sense from distance. So we don't have real scientific proof, but we can sense it. So all these are natural phenomena. Telepathy, right? So if you are sitting with your friend for 4 or 5 years, you know what, how your friend will react, because strong correlation between you and your friend. So this is possible, scientifically it is possible, creating an entanglement. But if you create an entanglement, if you are separating particle from one space station to another galaxy, these properties are always related. So whatever happens for one particle, you can see the immediate impact in other particle. So if you want to understand, you can take example of rock, paper, scissors. If 3 persons are playing rock, paper, scissors, so how will you decide who won, who lost? Based upon their choice. So instantly you can decide who is the winner, who is the loser. So measuring one instantly decide the state of the other faster than the speed of light, theoretically. So it is an example. We will see another scenario. Take 2 photons, 2 electrons, make strong correlation in laboratory, then separate them. If you try to change one quantum particle, you are rotating this quantum particle to downside, okay? The other quantum particle also move to downside. It is like a black magic. So in Indian horror movies, what they will do, they will take some doll, okay? They try to relate with some live person. Whatever they do, torture for this doll, you can see the same effect. It is an example for entanglement. So if you rotate this particle to upwards, automatically that particle also move to upwards.
Sir, is that it proves that whatever they are doing on the black magic, is it true it is going?
Scientifically, we should not believe as an engineer, right? But if you want to threat your friend, you can use this. So this is natural phenomena. Okay, scientists able to demonstrate, but they are not able to understand why it is happening or how it is happening. Still it is mysterious. Because of this, Einstein rejected quantum principles. Okay, quantum entanglement. If you are not able to convince scientists, they won't believe, they won't accept. So I will give this simple architecture of cryogenic quantum computer. So it is made up of quantum particles. So basic building block of quantum computer is quantum particle, and you can use to construct qubits. Qubit stands for quantum bits, bits stands for binary digits. Okay, so you can take any particle. You can select electron, you can select photon. So depending upon your selection, the architecture will differ. So this is the basic phenomenon. So based upon your selection, the architecture entirely differs. Okay, so all these quantum particles have some property. Take an example of electron. So electron has spinning property. Photons have polarization property, like UV glass, or you can say polarized glass. Okay, Ray-Ban glass. So these polarization have horizontal polarization, vertical polarization. Sometimes you can have diagonally also. The same glass have tinted feature. So upside you can have darker shade. So downside you have lighter shade. Okay, if you tilt your eyes, you can see different worlds. So we are using this property to represent our data. So if electron spinning upwards, state 0, spinning downwards, state 1, in between superposition. So same go for polarization. Horizontal means 0, vertical means 1, in between means superposition. So we are using properties of a quantum particle to represent our data. Okay, so for a single quantum particle, you can observe superposition. To observe entanglement, at least you need to have two quantum particles. So if there is a pair, at least two persons need to be there. Same idea. But you can create entanglement for 100 qubits, 1000 qubits, million qubits. Suppose if you are creating entanglement between 100 qubits, how it look like? We will go for previous slide. For two particles, strong entanglement is created. If you are moving one quantum particle, the other particle also move in same way. But if you have 100 quantum particles, if you entangle all 100, how it look like? Yes, ma'am.
Previous slide.
I will show.
The previous slide you said superposition leads to one particle.
One particle.
Superposition actually leads to particles, right?
No, one quantum particle can exhibit superposition.
But we need to have at least two particles to issue. Because some states to be there to happen as superposition. With one particle, how you can have a...
Within one particle, you can observe two states, multiple states, not only two states, multiple states. Suppose if you are tossing a coin contains head or tail, but during flip, you can have different of combinations. So tilted, right? So superposition is always varying. So you can imagine like fan regulator. Suppose if you have fan, if you have a direct switch, if you are switching on, fan will get operated. Okay? If you have 5-level regulator, how many modes you are able to operate that fan? 5 level plus 2 off state, okay, on state 0, on state 1, if you had 7 states. If you remove that 5 level, if you are keeping, if you are plugging continuous regulator, infinite mode you can able to rotate that fan. So that is the same idea. Infinite states, theoretically. I will explain more. So two quantum particle means if you move one, the other also move in same way. 100 quantum particle means if you move one quantum particle, remaining 999 will move in same way. Looking like a military march past. So in military march past, one commander is there, remaining everybody will obey that command. But in quantum, everything is acting like a commander, everything will act like a soldiers. Okay? So any quantum particle can act like a commander. So remaining will act like a soldiers. So that is why if you have superposition, you can represent any kind of information. If you have entanglement, we have beautiful coordination, like synchronized coordination. Now it is clear, ma'am? Superposition. Okay.
Superposition to one position, it is not possible, sir, in quantum.
One position means, ma'am?
Means exact, it is different states you are telling, no?
Yes, ma'am.
It is not possible to move into the exact one quantum.
Very difficult to retain in one position because it always go for random motion. Random motion. We'll discuss. So if you have more number of entangled quantum particle, then you can go for quantum algorithm. So if you want to write quantum algorithm, you need to have enough number of quantum particle, entangled quantum particle. Okay? So in each and every quantum algorithm is designed by quantum logic gates. Whatever you have classical logic gates, they have equivalent version superior than classical logic gates. We have quantum logic gates. So all these logic gates will operate on your quantum particle. So if you apply each and every quantum logic gate, it will change your quantum particle location or position. It will change quantum state. So what is the advantage? You will get computational speed up. 5 times, 10 times, 100 times, 1000 times, million times. Exponentially you can have speed up. So comparing classical supercomputer with a quantum computer is comparing a bicycle with a bullet train. So whatever you do modification within your cycle, you cannot speed up. Fundamentally, it is totally different. The way it is computing, the way it is behaving. So it is a true parallel processing, simultaneous processing. Okay, each and every operation in quantum is compared to parallel processing or simultaneous processing. So after doing all this stuff, what you are supposed to do? You need to do measurement. Once you do measurement, what happens? The superposition will get collapsed. You will get classical output in high accuracy. So we have our binary data. Our binary data need to be encoded in quantum state. We need to do superposition, entanglement, we need to do process. So finally what we supposed to do? We need to do measurement. Once you do measurement, superposition state will get collapsed. Multiple options are there, outputs are there. From multiple outputs you will get only one output as the final result. So final result you have high accuracy, theoretically.
Sir, is there any method after at the end of the measurement, is that it is going to retain the information?
Your information is, you got information in the term of binary bit, not in quantum form.
Ending we are getting the result.
Yes ma'am. Quantum state you cannot retain.
No.
It is like, imagine quantum state is like a soap bubble. Okay, if you try to touch the soap bubble, what happens? It will burst out. So if you try to measure quantum state, you will last for it forever. So it is like you have a big hammer, you are striking over an egg. Once you strike, what happens? The form of that egg collapses forever. You cannot go for previous state. Okay, so doing measurement for quantum particle is looking like a major accident.
Other than teleportation, many methods are there.
Yes, ma'am.
Is it possible that retaining of the superposition content?
You cannot retain, ma'am, because randomly it will change. That is the difficulty, that is the advantage we have. Imagine we all belongs to Homo sapiens. We share most of the 99% of DNA, but are we looking same? So much of difference because of randomness, mutation. We don't know how it is happening, by the nature it will happen. Even for your prints, fingerprints, it will keep on change. From your childhood until your death, even your fingerprints will get changed. Even your face will get changed. So for doing this, you need specialized hardware. Okay, what type of hardware? You need to maintain ultra cold temperature for this architecture. So it will slow down quantum particle. So what is the advantage of superconducting quantum computer? It will slow down your quantum particle, you can use for computation. So all this stuff done by microwave pulses, all this wire will communicate through microwave pulses, able to control your quantum particle. Otherwise you can use laser beam. So China is investing majorly in optic based quantum computer. Okay, ion trap. So this is the interesting part, decoherence. So anybody know decoherence before this? In previous lecture, are they covered? Okay. So this is the idea which limits quantum computer hardware evolution. This restricts. Okay. A quantum system has to be isolated from its surroundings to keep quantum behavior, because we are dealing with delicate quantum particle, a finest level of particle, right? So whatever happens outside your environment, pressure, stray particle, temperature, vibration, electromagnetic fields, variation in these will act like a noise. It will change your quantum states, it will completely create an error in your quantum computation. So each and every qubit, this noise will accumulate. Even your body temperature, okay, your voice, okay, your presence, it will create electromagnetic fields. That is why we need to separate from surroundings by keeping this shield. So normally we created superposition along with entanglement, always chosen by chased by decoherence. So decoherence is a decay property. So whatever you create superposition and entanglement, it will decay in certain time limit. It will hold for milliseconds. So before decoherence happens, you need to do all your computation. So imagine if you have an apple. So if you have apple in your room, so how long it will be in normal mode or fresh? How long it will be in fresh? 1 day or 2 days. But if you are keeping apple inside a fridge, what you are doing? You are separating apple from surroundings. So the reaction between the environment, bacteria, virus, it will keep on stay away. But after 1 week, you cannot use that apple. So decay will happen within fridge, but happen in slower rate. Same idea. Okay. So decoherence is a natural phenomena. Your quantum superposition entanglement will decay. Okay. But if any one of these noise happening within your lab, it will accelerate this speed, accelerate decoherence timing. So before that, what you supposed to do? You need to complete your measurement. If you complete your measurement, you will get binary data. Binary data you can store for many years, no issue with timings. Is it clear? So this is the point. Exposure. Any exposure to noise lead to loss of quantumness. This process is called decoherence. So note down this slide. Any exposure to any one of these noise means all these noise, leads to loss of quantumness. This process is called decoherence. Whatever you do, decoherence will happen, but we need to delay that decoherence. That is the idea. Because of this, we are not able to create quantum hardware rapidly. So we can see how powerful quantum computers are. Suppose if you have 100 qubits, 100 electrons, 100 photons, okay, or 100 ions, there are total 10 to the power 24 stars in the night sky, but you can represent 10 to the power 30 states by using 100 qubits. Not even your supercomputer can represent this much of information. Suppose if you have 100 qubit quantum computer, you think how much data you are able to process simultaneously. Suppose if you have 300 qubits, okay, there are totally 10 to the power 80 particles in observable universe. But if you have 300 qubit system, you can represent 10 to the power 90 states. So no supercomputer can do this. Even if you combine all computers in this world, you cannot represent this many states. So these are examples. To understand this, we need to compare with classical bits. So I will share this slide, you please go on. So we will start from basics. Bits means it is a binary digit. Bit means it is a binary digit. It contains only one of the two states at a point of time. Suppose if you have a transistor, if you have a flip-flop, if you have a capacitor, if you want to represent 0, what is supposed to do? You need to discharge fully. Okay, if you want to represent 1, you need to fully charge. So between these two states, we have 2 instruction cycle or 1 instruction cycle. You need to have that time delay. Okay, at the same time, you cannot represent both states. But qubit means it is a quantum bit, quantum binary digit. It is in the representation of superposition, which is the meaning of psi. 0 to some extent, 1 to some other extent. So this is a block sphere. So it has state 0 like x-axis, state 1 like y-axis. So imagine this is pure white, this is pure black. So in between you have grey color, combination of all black and white. Okay, so this is superposition state or mixed state, you can say in this way. So this position, this symbol is called psi. So if you have a single qubit, what it can represent? It can represent multiple states. Minimum, you can represent 2 states. That is the meaning. At the same time. Classical, you cannot have these options. Either one. But here, you can represent both. So, yes sir.
Maybe you will explain that. Because representing a state by one line and say any significance.
This one, sir, I will explain in upcoming slide. You just understand this. Within a single device, single photon or single electron, you can represent both combination. So previously it is not possible. Only one possible states. So here the power is get doubled. Are you able to get the idea? Here the power is get doubled. Suppose if you have 2 qubits, Q1 and Q2, 2 quantum bits, okay, you can represent 0, 0. This is like normal classical. If you have 2 resistor, you can represent 0, 0. But in quantum, you can represent 0, 1, 1, 0, 1, 1 simultaneously. Like the previous one, at the same time, you can represent 4 combinations together. Not only representing, you can do computation, but if you do measurement, you will get one possible outcome. Are you able to get the idea? So in previous slide, if you do measurement, either you will get 0 or 1. In this case, either you will get 0, 0 or 0, 1 or 1, 0 or 1, 1. So adding 1 qubit, you are able to increase exponentially the data representation. So you minimized 4 instruction cycle. So classical, you need 4 instruction cycle. So in quantum, within single instruction cycle, you can represent all possible states. For 3 qubits, 8. For 3 qubits, you can represent all 8 possible states simultaneously within single instruction cycle. So you are not only reducing the time, and also you are increasing computational capacity. So this is very important slide. If you understand this, you understood from morning. 1 qubit, 2 states. If you are adding 1 more qubit, it will double the number of possible states. Look at 2 qubit, 4 states. Okay, 3 qubit, 8 states. So adding 1 more qubit will double, not only double, it increased exponentially. Where we discuss this topic?
Logic design.
Logic design, okay. Bits.
Yes. Yeah.
First slide. First question. Moore's law. Moore's law talking about double the number of computation power. Here we are doubling the computation power. So quantum comes like savings Moore's law. So it will hold Moore's law forever. Classical will fail, but quantum will help you. So if you add 1 more qubit, you can see increase. 50 qubits, 1 followed by 11 zero states. Just 50 qubits, 1 followed by 11 zero states. If you have 50 bits, you cannot represent simple text file. Okay, our computation limitation is very limited. So this is the block sphere. If you want to visualize qubit, quantum bit, you can use block sphere. So here we are taking radius equal to 1. It is a unit circle. Okay. So it is a unit circle. We are using x-axis like state 0, y-axis like state 1. Both are perpendicular to each other, orthogonal to each other. Sorry, orthogonal to each other. 90 degree it will maintain. So it represents opposite polarity. So this is black means that is white. This is true means that is false. Right? So in between what we are having, we have superposition. So electron will move from state 0 to state 1 continuously, randomly. Okay? Imagine your electron is here. From here you are generating a vector. It means it is a quantum state vector. So quantum state vector will give information about your quantum particle, where it is located. So if you want to do quantum computation, it will know its location, its quantum states.
So in the previous slide regarding the Moore's law,
Yes, sir.
you were just saying that it is satisfying with respect to according to the Moore's law.
Yes, sir.
But when we are just in 2004 or 2005, when we were just looking, the Moore's law is already broken, and we are increasing the number of transistors. We are adding up the number of transistors for every 2 months now.
Okay.
And now, when we are adding the qubits,
Okay.
it's also increasing according to, right?
Increasing.
Number of
Increasing.
qubits are also increasing.
Increasing.
But how is going to satisfy the Moore's law condition? Again, the Moore's law is also broken, right?
Moore's law broken because you cannot reduce the size of transistor. You cannot reduce the size of transistor. You are not able to double the number of transistor. If you keep on do, heat dissipation will be there. You cannot handle your processor. So no more new processor means no more hardware upgradation. No more hardware upgradation means you cannot take challenging projects. So Moore's law is already failed. But if Moore's law fail, what happens? IT and CSE will get stagnated. It will impact all other domain. It will lead to global recession. So it is important to keep Moore's law at least by doing in quantum bit. So that is the idea. To understand the qubit, we need to understand it is like a electron moving from here to here continuously. Imagine electron is located here. We are generating a vector from origin. It is quantum state vector. So in quantum will represent state. So we have two basis state. Like in graph we have two axes, right? X axis and Y axis for reference. Same way we have basis state, state 0 and state 1. So 0 represents ground state, down state, 1 represents excited state or up state. We studied in physics in laser. So excited state, okay, ground state, minimum energy. So this is the notation. This is bracket notation. This is bar, this is greater than angle. If we combine together, it is called bracket notation. So this is ket notation. So if you reverse this notation, it is bra notation.
Sir, can you repeat that?
I will draw, sir. I will draw. So this is ket 0, this is ket 1. So ket is column representation, bra is row representation. I will show all this. So we have a block sphere you have unit radius. So imagine psi 1, your electron is in psi 1. Okay, in psi 1 it is creating 45-degree angle. So what it means? You have electron in psi 1, okay, it will create 45-degree with state 0. What it means? So 45-degree to state 0 means how much angle it will create with state 1? 45-degree, because 90-degree, it means it is in equal superposition. So note down. So if it is in equal superposition, it is 50% away from state 0, 50% away from state 1. It is like a fair judge. So if electron is moving from state 1, psi 1 to psi 2, it means it will create 60-degree with state 0, 30-degree with state 1. So it is more near to state 1, far away from state 0. When you do measurement over here in psi 1, 50% of the time you will get value 0. 50% of the time you will get value 1. But if you do measurement in psi 2, most of the time you will get binary value 1. Less number of time you will get binary value 0. Okay, so it is like how close you are to chief minister or higher official, more easily you will get your work done, right? Same idea. So to represent superposition, you need to have this equation. Psi equal to, so note down this equation. Psi equal to alpha multiplied with state 0 plus beta multiplied with state 1. So we have two states in quantum, this block sphere. Okay, so we need to add all quantum states. So recall the definition of superposition. You need to add all quantum states. We are adding all quantum states. So this is linear combination. So for 1 qubit, 2 states. For 2 qubits, 4 states. 0, 0, 0, 1, 1, 0, 1, 1. So we need to add all 4 states. For 2 qubits, we have 2 values, alpha and beta. So these are acting like complex numbers. So alpha and beta are the variable or parameter associated with state 0 and state 1. So complex number means it will contain real value, it will contain negative value, it will contain imaginary value. So these will act like pre-amplitudes. Alpha and beta will act like pre-amplitudes. For equal superposition, we will get this state. 1 over root 2 multiplied with state 0, 1 over root 2 multiplied with state 1. Now compare this with the equation. What it means? In equal superposition, we have 1 over root 2. Where is studied 1 over root 2? For 45 degree. Sin 45,
Cos 45.
1 over root 2, cos 45, 1 over root 2. So only during 45, sin and cos are equal. Now we need to understand how to measure these alpha and beta values by doing two projections. Imagine your electron is over here. Imagine your electron is over here. From this point, if you are doing projection for x-axis, it will reveal the value for alpha. If you are doing projection from this point to y-axis, it will give value of beta. Okay, imagine if you have electron over here, what happens? You will have more value for alpha, less value for beta. Imagine if you have electron over here, okay, more value for beta, less value for alpha. So depends upon your electron location, okay, alpha and beta will get varied. Yes, okay. Not charging, sir. Charging, sir. Now charging. Fluctuating, sir. Fluctuating. Bandilla. Now charging. Charging. Andilla, sir. Alli, sir. Alli. Charging, sir. So note down, alpha is amplitude of state 0, beta is amplitude of state 1. When you do measurement, superposition will get collapse. Either it will choose state 0 or state 1 by force. So in quantum, everything is supposed to see like a signal. Okay, you need to measure in the terms of amplitudes. So measurement is crucial. During the last step, you're supposed to do measurement. So if you want to know what is your probability, okay, what is the outcome of your probability, what you're supposed to do, you need to take modulus of alpha. If you take modulus, you will get only the real quantity. Okay, you are forgetting about the direction, you are looking only for the magnitude. If you do square, you will get only positive value. In quantum, everything is real. Even though we have imaginary, when you do measurement, you are looking for the real values. So imaginary doesn't exist. We are adding imaginary only for computation purpose. Same way, if you want to do the probability of state 1, you need to do modulus of beta and you need to do square. So finally, what you are supposed to do, you need to add all probability, like normal probability. If you add all together, you will get sum equal to 1 or 100%. So this is the only place the classical probability and quantum probability will come together equally.
State வந்து collapse ஆயிருக்குங்க.
ஆமாங்க சார்.
அப்ப collapse ஆயிருச்சு அப்படினா நம்ம எப்படி மெஷர் பண்ண முடியும்?
ஸ்டோர் பண்ண முடியாது few seconds தான்
அல்ல what I supposed, imagine your quantum bit is like a soap bubble. If it touch, what happens? It will burst out, but it will burst out at a particular point. That's all. So if you have quantum bit, so it contains multiple possibility. If it is more near to 0, more likely you will get binary value 0. More near to 1, you will likely able to get binary value 1. But it behaves like randomly. Even though it is near to 99 point, near to 0, occasionally you will get binary value 1 also.
ஸோ அதே மாதிரி இப்போ வந்து 50 qubits இருக்குது அப்படின்னா 2/50 அப்படின்னு சொல்லிட்டு இத்தனை ஸ்டேட்ஸ் இருக்குன்னு சொல்லுவோம். அப்புறம் எதுக்கு நம்ம வந்து அதிகமான qubitsோட கவுண்டை இன்க்ரீஸ் பண்ணிட்டே இருக்கோம்?
Sir, we need to select only one outcome from possible number of states.
ஆமாம் சார், அதை வந்து நம்ம இப்போ ட்ரெயின் பண்ண முடியாது. இப்போ ஐடிஎம் வந்து 1/21 qubits வந்து டிஸ்கவர் பண்ணுறாங்க. அதில் இருக்கிற ஸ்டேட்ஸ் வந்து ஒரு ஸ்டேட்டை தான் நம்ம எடுத்துக்கிறோம். ஆனால் மேத்தமெட்டிக்கலி ஃபீஸிபிள் இல்லை, அத்தனை ஸ்டேட்ஸ் கொண்டு வர முடியாது அப்படிங்கிறது நம்மளோட ப்ரொஜெக்ஷன்.
Mathematically it is feasible, sir.
மேத்தமெட்டிக்கலி ஃபீஸிபிள் அப்படின்னா ஒரு நார்மல் கம்ப்யூட்டரில் நீங்கள் 2/1 போடுறீங்க அப்படின்னா ஒரு பாலினாமியல் உங்களுக்கு கிடைக்காது.
ஆமாம்.
அப்போ நம்ம எப்படி மேத்தமெட்டிக்கலி ஃபீஸிபிள்னா குவாண்டம் கிட்டில் மட்டும்தான் இருக்குது.
Mathematically feasible, quantum hardware is not evolved that much. We need to wait.
ஸ்டார்ட் பண்ணும்போது நீங்கள் ஒரு வார்த்தை சொன்னீங்க, எல்லா இதுக்கும் வந்து குவாண்டம் இஸ் நாட் அப்படிங்கிறது.
Yes, sir.
எதுவுமே நாட் ப்ராப்ளம் எது இருக்கோ அதுக்கு வந்து குவாண்டம் அப்படி.
Okay, I will come to in this way. If your problem have random computation, random value, permutation, combination, in those places you can go for quantum. So you can note down this. If your problem contains random computation, random value, or much more permutation, combination, you can go for quantum. So if you trace the movement of this quantum particle, you are able to trace like a sine wave. You are able to trace like a sine wave. Okay. So this is the amplitude of a given wave. So amplitude determines the probability of your outcome, either 0 or 1, based upon your alpha and beta value strength. Okay. But once you do measurement, the amplitude converted into probability. So wave is nothing but a physical movement of any function. So what we study in mathematics, it represents a graphical representation. So which one is important? Physics is important or mathematics is important?
Both are important.
So basically there is no mathematics, everything related to physics. To solve physics, to visualize, to abstract, we are using mathematics like a tool. Once you have tool, you can apply for any subjects. So mathematics is just like abstract. So mathematician will say everything came from mathematics. Not like that. Everything came from real objects. For solving real-time problem, we are using math like a tool. So there is no conflict, which one have priority. So we need to use math like a tool, right? So I can compare like a wall clock. So you can note all these places, okay? And you can take the horizontal axis as 0 and you can compute how far each module from horizontal axis. So take an example of 2, how far away 1 unit. Take an example of 1 o'clock, how far away 2 units. You replace this. So downside, you replace with negative quantities. So this is an example. So if you plot, it will appear like a wave. It will appear like a wave. So if you want to represent a wave, so this is a physical movement we are tracing through graph. So we have a wave, so wave have wavelength, okay, so wave have period, so this is the amplitude. If you are adding two amplitudes, okay, sorry, 2 waves at the same pattern, what happens? Amplification will happen. Amplification will happen. Okay, if we add 2 waves of opposite pattern, it will nullify each other. So we are using this principle in quantum computation. Sometimes you need to amplify your correct answer, sometimes you need to nullify your wrong answers. So everything we are doing through signal interference, wave interference.
Is this one amplitude adding and cancelling, it is related to amplitude encoding?
No ma'am, no. If you are doing any computation in quantum, everything you need to wave like signals, waves, interference. So during that time you need to use these 2 techniques. Already we know. So amplitudes will influence your outcomes. So that is the crux. Amplitudes will influence your outcomes. If you do quantum computation, it will give correct answer, it will give wrong answer, it will give combination of answers. Your quantum computer will not only give the correct answers. So I will give some example. So you can note down this tool, open board. So if you are teaching, this will be helpful. So I have 2 different computation. One is classical, one is quantum. Suppose if you have problem 2 plus 2. Suppose if you have problem 2 plus 2. So your input is A equal to 2, B equal to 2 and C equal to A plus B. If you are writing program for classical computer for first iteration, what is the output to expect? So first time you will get 4, second time 4, third time you will get 4, fourth time you will get 4. In quantum, first time you will get 4, second time you will get 3, third time you will get 2, fourth time you will get 1. For the same input, for the same operation, in classical you get the same output, because it is due to deterministic computing. If you know your input, if you know your process, you can predict your output. In quantum, you cannot predict your output. For the same input, for the same process, you will get different outcome. Each and every time your output varies. So in this case, quantum is inefficient for addition process. This is due to probabilistic computing. So note down this. So this is due to deterministic.
Probabilistic அப்படினா 3.99 3.
Yes sir, I will tell sir, I will tell sir. So if you are running for 4 times, you cannot differentiate which one is correct, which one is wrong. To understand this, we need to run multiple times. Suppose if you are running for 100 times, then you can see the statistical difference. Okay, for 80% of the time you will get 4. Okay, for 10% of the time you will get 3. For 7% of the time you will get 2. For 3% of the time you will get 1. To understand your quantum output, you need to run for multiple times. Whether it is feasible, whether it is justifiable. Take an example of dice. If you are rolling for a single time, if you got value 1, can you conclude dice only contains single value? You cannot. You need to roll for multiple times. Suppose you are rolling dice, you are getting continuously one value for 2 times. You cannot conclude. But if you are rolling for 100 times, you will get different probability, different outcome. So in this way, quantum is justified even though you are doing for multiple times, it will take less time when compared to classical computation. For some data, you need to run for multiple times. Okay? During that time, quantum will beat you. So this is why I mentioned over here, if you are doing quantum computation, you will get correct answer in it, you will get wrong answer. To increase correct answer, you need to amplify. To reduce wrong answer, you need to cancel by doing those interference, amplification and nullification. So we need to do so much of manipulation. So theoretically it will look very simple, but we need to do so many manipulation during our computation. So I'll skip this. Already we know all this stuff. You can note this point. You can note this point. To get probability, what we are supposed to do? We need to take modulus, we need to do square. So if you do this process, then only you will get probability in quantum. So just note down this formula, it will help you during calculation. So if you are doing modulus, you are not considering about which direction it is pointing. You are only focusing on value of alpha and value of beta. Square means definitely you will get positive value. So try this. Take modulus of 1 over root 2, do square. What is the value you will get? 0.5. So if you add 0.5, 0.5 equal to 1. So this is the recall, refresh about the measurement. So measurement changes amplitude into probability. You need to do measurement to get binary result. So always measurement will yield random answer, not correct answer, not wrong answer. It is the mixture of multiple choice. So a single qubit have two potential outcome, either 0 or 1. Okay. For single qubit, we have two outcomes as amplitudes, alpha and beta. Okay. For two qubits, we have four combinations. We have four combinations, four amplitudes. So you need to realize how many qubits are there, how many possible outcomes are there, and how many amplitudes it will involve. So all your outcomes associated with amplitudes. All your outcomes associated with amplitudes. So amplitudes can be controlled by using your quantum logic gates. That is the purpose of quantum algorithm. So you need to control your amplitudes in order to give correct answer. Okay, it will do interference, it will cancel out unwanted noises like noise cancelling headsets. Okay, we know which one is noise. Once we recognize which one is noise, we will cancel out. During computation, after so many iterations, we are able to identify which one is noise. So if you want to write quantum algorithm, you need to made up of using gates and rules, quantum logic gates, which will manipulate amplitudes. Okay, so each and every time if you do quantum gate operation, it will do interference. So you can consider like a water body. Each and every time if you are changing any quantum gates, applying quantum gates, it will create wave interference in your water body. So like a continuous ripple. So amplitudes will cancel for wrong answers, need to be cancelled. It will add an amplitude for right answers. So finally if you do measurement, more likely you will get desired outcome. More likely you will get desired outcome. For doing that, we need to run multiple times. So these are the classical gates. So gates will act like actual gate, okay, logic gate. So it will check one or two statements, it will examine. If condition satisfied, it will allow or it will deny. Example, AND gate, OR gate, NOT gate. So two conditions are checked for AND and OR. So in NOT only one condition is checked. So quantum logic gates, we have four important gates: bit flip, phase flip, Hadamard, CNOT. So take an example of bit flip. So bit flip is a NOT gate. So classical NOT gate. It is not a quantum gate, but in quantum you can implement all classical gates. But in classical you cannot implement quantum gates. So that is the difference between quantum and classical. So consider quantum is like superset. Okay, so classical is subset of a quantum. So whatever you do in classical, you can do in quantum. But whatever you do in quantum, you cannot implement in classical. So NOT gate, what is the action? In stage 0, your quantum particle is residing over there. If you are implementing NOT gate, X gate, it will turn into state 1. So if you are implementing NOT gate, what happens? Quantum particle move to state 1. Okay? In superposition, what happens?
You mean to say NOT gate, logical NOT gate is mentioned as bit flip gate in quantum?
Yes, sir. Bit flip. State flip, bit flip, you can consider in any way. Okay. For superposition, I gave clue in this equation. Alpha multiplied with state 0, beta multiplied with state 1. Imagine you have a qubit. So you have quantum vector over here. Okay, this quantum vector have alpha, beta. If you apply NOT gate, it is near to state 1. If you apply NOT gate, these values are interchanged. It will come near to 0. It will come to near to 0. So this will happen. Are you able to understand? So alpha, beta will interchange if you apply NOT gate. So imagine your deepest friend, dear friend, one fine day turn into enemy, become a powerful enemy because he know each and everything about you. Right? Powerful enemy. Going for opposite party. In equal superposition, if you apply NOT gate, in equal superposition, if you apply NOT gate, it doesn't have so much of impact. Okay, alpha and beta always 50. If you interchange also, it will become 50. Are you able to understand this? Pure state, this is superposition state. Okay, so next one is phase flip. Next one is phase flip. So I have state 1 and minus state 1 and you have state 0. So flip gate, phase flip gate, Z gate only operate in state 1, not in state 0. So state 0 doesn't have negative sign. So if you apply Z over state 0, it will retain state 0 as it is. So Z gate will act like identity gate. So note down this. So Z gate will act like identity gate. So nothing will happen if you apply over stage 0. But if you apply in state 1, it will flip sign from positive to negative. From 0, if you apply Z gate, okay, it won't change anything. It act like a identity gate, nothing changed. Okay, but if you add over state 1, it will change sign of state 1 into negative. That is why it is phase flip gate, Pauli gate, Pauli Z gate. If you apply from state -1, it will move to state 1. So what happens in superposition? Again, clue is that equation. It will change sign for which part? It will change only related to state 1. So, the sign is changed only for beta, not for alpha. So, mention this reason also. So, positive flip now turn into negative flip. So afternoon we will do all these things in lab during a demo or toolkit. Okay. So afternoon is important. Please turn up. Okay. So if you apply Hadamard gate from stage 0, it will go to equal superposition. If you apply Hadamard gate from stage 0, it will create equal superposition. So in between stage 0 and state 1, we looked psi 1, right? So psi 1 can be created by using Hadamard gate. So tossing a coin. So if you toss a coin, what happens? Superposition is created.
Means once we apply Hadamard, always it will be superposition.
Always it will create equal superposition. This word is important.
Sir, what characteristics of Hadamard gate
Yes, sir.
makes to work like that? Something.
Because you need to create randomness. If you are creating fair randomness, then only it is valid. To create randomness, it should be neutral. You cannot predict where it will go. So it is like cat in middle of wall. The cat don't know where it will jump. You cannot predict where cat will jump. So it is true randomness. So in this sense I am talking about. So from state 1, if you are applying Hadamard gate, it will go to negative state. So only one difference. From 0, it will create positive state. From 1, it will go for negative state. So mathematically we are describing. So during demo, we will have visualization. Don't worry. If you can't understand, we go for demo. So in superposition, where it will go? Already it is in superposition. If you apply Hadamard, it will create new superposition. So note down this point. Don't write all this formula. I will share with you. If already quantum state in superposition, if you apply Hadamard gate over that position, it will create new superposition. Not same position, ma'am. It will go for different position. Maybe in the same level also, but it will go for different place. I will show with the block sphere 3-dimensional. 2-dimensional you cannot visualize. So what is the time until 1 o'clock? Until 1 o'clock. Okay, this is 2-dimensional. I will show in 3-dimensional. So this is more than enough. So note down this web page, group blotch. Blotch, if you Google group blotch, this page will come. GROKBLOCH. So this is 3-dimensional block sphere. So far we discussed only 2-dimensional. Now we are entering to 3-dimensional. So this is your sphere, this is your sphere, okay. So this is northern hemisphere, this is southern hemisphere. We are dividing our block sphere into 2 hemisphere to represent state 0 in upper side, state 1 in lower side, okay. So this is state 0 and state 1 are called pure states. So note down. So this is state 1 and state 0 and state 1 are called pure states. So these states generated from binary data. So binary we have value 0 associated with state 0, binary ones associated with state 1. Now your electron pointing to north pole. In north pole we fix state 0, okay. So this is NOT gate, this X gate is NOT gate. If I click NOT gate from this point, where it will go? This is state 0, so it will go from north to south pole. Exactly. So from state 0, if you apply NOT gate, it will go to south pole, state 1. From state 1, again if you are apply X gate, where it will go? It will go back to state 0. So this is the first point. So note down, from state 0, if you apply NOT gate, it will go to south pole, opposite state, bit flip or state flip. So next one is Y gate. Y gate is equal to NOT gate, but Y gate have additional property. It is a quantum gate. So X gate is classical gate, Y gate is quantum gate. It will do bit flip along with state flip. So look over here, from 0 I applied Y gate, it did bit flip, but downside you can see difference, phase flip. From 0 it went to pi/2 rotation. So this give additional computational capacity. Are able to get the idea? I have a hand, I am able to point to upside, I am able to point downside. So this is NOT operation, okay. If I am able to tilt my hand pi/2, I have additional degree of freedom, so I can do more works with my hand. Same idea. So Y gate have additional computational capacity when compared to X gate. So likewise, each and every quantum gate have additional capacity. They got new superposition, they can do more computation. Imagine if you have single hand, how much work you can do. If you have both hands, your capacity is increased. More degree of freedom is more work you can do. Ma'am, if you go to lab, it will be very clear. Here it is not that much visible. ஆகும் சார், இங்கே பாருங்க, state 1 pi/2. So click Y gate again. Now it is coming to state 0, full signal. So you can see E value is now 0. So if you do any change in phase, you can notify over here. So look at here, if I apply X gate, it will come down. So 0 it is pointing. So in pi value, in phase value, you never get any changes. Okay, click 0, apply Z gate. From 0, if I apply Z gate, what is the concept we study? No change. So it will act like identity gate. So quantum state will retain as it is. Like a pause gate, pause button. Okay, if you want to retain, you can use Z gate in stage 0. So click state 1, apply Z gate and observe what happens. So phase is shifted to pi rotations. So you cannot see physical change, but downside you can see phase change. If you change phase of a signal, the entire information is changed, right? The same idea. So Z gate will act like phase change. So click 0. Now apply Hadamard. What happens? It will create equal superposition. This is your equator. So it will create equal superposition, 50% away from stage 0, 50% away from state 1. If you do measurement, 50% of the chance will get value 0, 50% of the chance will get value 1. True random number. For a single Hadamard gate, you cannot predict its outcome. Never ever possible from quantum. So it is true random. Okay. Now we are in positive state, x-axis. From here again, if you apply Hadamard gate, it will go back to stage 0. So applying 2 x gate will cancel each other, go back to original. Apply 2 y gate next to next will cancel each other. Applying 2 z gate will cancel each other. Applying 2 Hadamard gate will cancel each other. It means all these gates have own inverse. So 5 minus 5 equal to 0. Likewise. So opposite nature. All these are single qubits. So click state 1, apply Hadamard gate, observe what happens, it will go to negative state. So each and every quantum operation are reversible in nature. If you want to do reversible computation, if you want to do back propagation, quantum will help you. So you can note down if your problem involved with reversible computation, okay, backward propagation, you can use quantum for that. Very good question, ma'am. Reversible is very hot topic. Okay, take an example of AND gate. We have two inputs. One output. Okay, so table will appear in this way. So AB output. So 0 0 means 0, 0 1 means 0, 1 0 means 0, 1 1 means 1. So if I am giving input, can you able to predict the output? If I am giving input combination, you able to predict the output. If I am giving the output, can you able to predict the input combination? Why? It is impossible, because for the same output we have 3 different input combination. You are not sure. In case of 0 for AND gate, you are not able to judge input combination, because you have 2 inputs. Okay, after processing you will get only one output. You lost your input combination. So 2 fan in, 1 fan output. Fan out. So 2:1 is problem for this. Just make it out. So what is the problem over here? We are losing the input combination during operation. So take an example of NOT gate. So A is 0 means B is 1. Okay, A is 1 means B is 0. These two are differentiable. These two are differentiable. Okay, this case is different, this case is different. But here, only the last one is differentiable. These three you are not able to differentiate, only the last case you are able to differentiate. So if it is differentiable, it is reversible. So note down this line. If your input and output combination are differentiable, it is reversible in nature. So how to fix this problem? Yes, ma'am. No, here, if you want to do reversible AND gate, whether it is possible or not. If you are able to maintain two outputs, then it is possible.
Different outputs, sir.
Which one, sir?
For each combination, I have to pick different.
Yes, sir. One like dummy output, one like actual output. If you retain, or if you are able to store this information subsequently, you are able to retain your information. So all these gates are reversible, but if you keep on doing all these gates reversible, it will cost you more. More number of fan in, fan out, storage, it will lead to inefficient computation. So reversible is possible, but you cannot do for all your data. The gates become more complex, the gates become more costly. So that is why this is reversible. From 0, if you apply Hadamard, it will come to positive state. From 1, if you apply Hadamard, it will go to negative state. So these two operations are reversible, distinguishable. Distinguishable means it is reversible. So all quantum operations are reversible in nature. All quantum operations are reversible in nature by default.
In quantum, it is able to predict
Which one, ma'am?
the inputs and outputs. For the particular outputs, all is
How many inputs you are giving, that many outputs it will generate. Equal number of fan in, fan out. So that is why it is reversible.
means for the hackers, it is easy to hack.
Which one, ma'am?
If it is able to predict the input.
You cannot predict the output in quantum. Even for the same input, you cannot predict the output. No. Within the quantum, you are able to do. But once you do measurement, you don't know. For 1 qubit, you are able to predict. For 100 qubit, for millions of possible states, how will you predict? So it is like kaleidoscope. Even though you are holding kaleidoscope, if you are rotating millimeter, you will get different pattern for each and every time. For analogy I am talking. So each and every time the output varies, the quantum state varies. Okay. So from 0 what I am doing? I am applying Hadamard gate. It will create equal superposition, it will come to positive state. From positive state, if I apply S gate, what happens? Is somebody covered S gate? Okay. So if you apply S gate, it will create phase shift in XY plane up to pi by 2 value. So I mean positive state, I created from stage 0, applied Hadamard gate, it moved to y axis. So x axis contains real inputs, real values, y axis contains imaginary values.
So, all these also shift the phase.
Yes, ma'am, I will tell the difference. So note down, x axis contains real value, y axis contains imaginary value. From positive state, if you apply S gate, it moved to y-axis pi by 2 rotations. So it is like I am moving my hand in between in this way. Are able to get. Using Z gate, I am able to tilt my hand. But applying S gate from equator, I am able to tilt my hand in this way. So I can do more operations. So from y-axis, if I apply S gate, what happens? It will move to minus x state, negative state. So it is not compelling with quantum, it is not reversible. Now we are hitting the problem. So what we discussed, each and every quantum gate need to be reversible. If it is not reversible, we are creating reversible gate for this. This is called S dagger. Whatever the S gate will do, it will do in opposite direction. From minus x, if I apply S dagger, it will go in opposite direction. Are you able to get the idea?
We have the lunches are already.
Okay.
Should we take a break and?
We can take break. So when we can reassemble? 2 o'clock?
2 o'clock.
2 o'clock.
Can you just show yes once?
From zero, apply Hadamard gate, it will come to positive. From positive, apply S gate, it will go to y-axis. From y-axis, again apply S gate, it will go to minus x-axis. So if you want to do reverse operation, use S dagger, okay, it will do reverse direction. Again one more S dagger, it will come back to original state. So as per rules, each and every quantum operation should be reversible in nature.
Whenever this reversible is not possible, we will move on for S dagger.
Yes, ma'am. Because it rotates only pi by 2. Z gate pi rotations. If you want to do reversible, then you can use for S dagger. So one more gate is there. So we'll wind up. So click 0, click Hadamard. It will come to positive. From positive, click T. Only 45, pi by 4. So more the freedom of movement you have. So I have my hand movement in this way, right? So in between I can stop. So more work I can do. Are you able to get the idea?
Step by step.
Step by step you can do. So imagine how many possible you can create with a single qubit. So in binary, only 0 is possible, 1 is possible. But look at the degree of freedom in quantum. That is why more computation you can do. Which one? From positive? Use Z gate. Now it is in positive. If you apply Z gate, what is the definition of Z gate? It will change sign, pi rotations. Very good question. We need to study. In our algorithm, some scenario we need to move our quantum state to pi rotation, pi by 2, pi by 4. During that time, we need to select our gates. So like logic gates, when we need to use AND, OR, XOR combination, it depends upon the logic. It depends upon the purpose. So thank you all. If you are not able to understand, come afternoon, we will do demo. Okay, you will have hands-on experience.
Vikram found the perfect package in seconds, so he could spend hours and hours relaxing. Expedia, made to travel.
युद्ध, संघर्ष, युद्ध स्थिति के दौरान असाधारण कोटि की विशिष्ट सेवा के लिए उत्तम युद्ध सेवा मेडल लेफ्टिनेंट जनरल कंवलजीत सिंह ढिल्लों।
पूरा देश अपने अपने घर, हर देशवासी अपने अपने काम करने में एकदम सेफ्टी से रहे, महफूज रहे, उसके लिए हर फौजी की एक जिम्मेवारी बनती है। अपने खुद के परिवार को, अपने खुद के घर को छोड़ के देश की सरहद पर ऐसी ड्यूटी दे ताकि देश महफूज रहे, देशवासी महफूज रहे। किसी परिवार में बच्चे का जन्मदिन मिस कर दो, वाइफ का बर्थडे मिस कर दो, अपनी एनिवर्सरी की डेट मिस कर दो तो हंगामा हो जाता है। जन्मदिन मिस करना तो क्या, मैंने तो जन्म का दिन ही मिस कर दिया। दोनों बच्चों का जब जन्म हुआ मैं घर पर नहीं था। दोनों बच्चे जब पहली बार स्कूल गए मैं घर पर नहीं था।
One feels sad that he's not around. You want to share these moments with the husband. But I knew he's serving the nation. So I was proud of him.
हर कोई फौजी को सलाम करता है। आप सोशल मीडिया पर जाइए, फौजी की फोटो डालते हैं, उनको जय हिंद बोलते हैं। बहुत कम कोई बोलेगा कि फौजी के परिवार ने कितना सैक्रिफाइस किया, उनका बलिदान क्या था। मेरी 39-40 साल की सर्विस में करीब 40 से ज्यादा घर 40 साल में बदले हैं। पहली पोस्टिंग सिक्किम में थी, 16,000 फुट 30 फुट बर्फ। वहां से निकले तो सीधा राजस्थान। वहां पर भी जब एक्सरसाइज में जाते थे, रेत के टीलों के ऊपर अंडरग्राउंड बंकर होते थे, बाहर 48 डिग्री 50 डिग्री टेम्परेचर। फिर कभी कश्मीर की घाटियों में, कभी इंडिया के प्लेन्स में, कभी रिवराइन एरिया में, कभी समुद्र तट के साथ। एल्टीट्यूड में, बर्फ के इलाके में जब मैंने नौकरी शुरू की थी, उन दिनों में पत्थर की दीवार के बंकर होते थे, वो घर होता था। तो लाइफ में बहुत से मिशन अंजाम दिए। एक मिशन जो बाकी था वो था रिटायरमेंट के बाद एक अच्छा घर बना के अपने परिवार के साथ जिंदगी व्यतीत करने का। जिंदगी में इंसान एक ही बार घर बनाता है, और जब आप घर बनाने निकलते हो तो आपको घर बनाने का तजर्बा करीब करीब 0 होता है। एप्रीहेंशंस बहुत होती हैं, आपके दिल में शक सवाल बहुत होते हैं। तो उसके लिए सबसे पहले जो सिलेक्शन थी वो थी सीमेंट कौन सा होगा। मार्केट में बहुत से सीमेंट है। मैंने जितने मेरे दोस्तों ने पिछले 8-10 साल में घर बनाए थे, जहाँ रिश्ते में घर बनाए थे, सभी लोगों से पूछा तो विदाउट एन एक्सेप्शन जो एक प्रोडक्ट क्लियर विनर निकला वो था अल्ट्राटेक। और उसके बाद जब मैंने अल्ट्राटेक को अप्रोच किया, नई चीज जो मेरे को देखने को मिली कि वो एक वैन लेकर के, मोबाइल टेस्टिंग वैन बोलते हैं, वो पूरी वैन लेकर के यहाँ साइट पर आए। उसमें बहुत किस्म के बीच में चीजें थी। एक उसमें था कि कंक्रीट टेस्ट, उसके अलावा उसमें था कि जो आप सैंड यूज कर रहे हो ऑन द स्पॉट उसकी सैंड की टेस्टिंग होती है कि सैंड में मिट्टी है, नमी है। एक होता है राउंड हैमर टेस्ट, मैंने पहली बार देखा, और ये सब उस वैन में था। और ये सब चीजें जो है ना, ये कस्टमर फ्रेंडली जो एक्शंस हैं, ये आपको एक डिसीजन मेकिंग में हेल्प करते हैं। विश्वास तो होता ही है, आंखों से देखना, आपके सामने सब कुछ हो रहा है। और जिनका ये तजुर्बा था कि बरसात में या सर्दियों में, गर्मियों में वो घर कैसे रहा। बात बरसात की हो रही है तो जो मैंने देखा है, अच्छी अच्छी बिल्डिंग्स सीपेज के कारण देखने में बुरी लगती, तो मेरे को यह बहुत जरूरी था कि घर में सीपेज नहीं आए, बाथरूम में सीपेज नहीं हो। घर की स्ट्रेंथ जो है वो उसकी नींव में है, उसकी दीवारों में है। लेकिन जब एक्सपर्ट से बात हुई तो पता लगा कि डैम्पनेस और सीपेज और लीकेजेस सबसे बड़े दुश्मन तो स्ट्रेंथ के ये हैं। जो नींव है, जो कॉलम्स हैं, जो पिलर्स हैं, जो उसमें कंक्रीट यूज होती है, उसमें भी एक वाटरप्रूफिंग मटेरियल है WP+200, वो कंक्रीट में मिक्स किया जाता है ताकि वो जो नीचे से उठने वाली जो नमी है उसको रोक सके। बाथरूम में पानी यूज होता है, नहाने के लिए यूज होता है, कपड़े वगैरह धोने के लिए यूज होता है, वॉशिंग के लिए यूज होता है। तो उसके लिए भी पहले जो नीचे मटेरियल जो आपने डाला है उसको पहले साफ करके उसमें SBR करके मटेरियल आता है, उसका एक लेयर लगाया जाता है। फिर उसमें जो हाई फ्लेक्स मटेरियल के 2 लेयर्स लगते हैं, उसके बाद में ऊपर उसके टाइल्स लगती हैं। छत में जब लेंटर डलता है, गर्मी के कारण उसमें माइनर क्रैक्स आ जाते हैं, जो कि बाद में बरसात होने के टाइम पे हो सकता है उसमें पानी अंदर जा सके। उसको पहले सफाई करके फिर माइक्रोक्रीट से उसको भरा जाता है। उसके बाद में हाई फ्लेक्स, फिर 7 डेज पानी खड़ा करके टेस्ट करना। तो जो बाहर का प्लास्टर है उसमें जो है वेदर प्लस, और अभी 3 बरसात हो चुकी है तो इट्स सक्सेसफुल। तो ये एक असिस्टेंस थी जो बहुत बड़ी हेल्प। सो थैंक यू फॉर दैट, दैट वाज वंडरफुल। ये जो जर्नी कह सकते हो, सफ़र कह सकते हो, घर बनाने का जो टाइम था, उसमें जो सबसे एक अहम बात थी वो ये थी कि ये घर जो है, इसकी पूरी डिज़ाइनिंग हमने 4 मेंबर्स ने, फैमिली ने, खुद ने बैठ कर किया। ये जो निचोड़ है, ये एक प्यार, एक इमोशन, एक फीलिंग, और वो जब कागज़ के ऊपर बैठ के लाइनें खींचते हैं घर की दीवारों की, घर की खिड़कियों की, छतों की, तो वो तमाम इमोशंस निचोड़ के वो पेन की स्याही से कागज पे बिखरते हैं। देयर नो रनर्स अप इन वॉर। सिल्वर मेडल नहीं है लड़ाई में। इसी तरह घर बनाने में भी सिल्वर मेडल नहीं है। अगर आपने सीमेंट कमजोर लगा दिया, नींव में अगर कमजोरी आ गई, तो वहां पे सीलन आ गई, वहां पे कोई क्रैक्स आ गए, तो फिर आप ये नहीं कह सकते कि मैं नींव को दोबारा कर लूँ। तो वो चीजें जो हैं, जो इरिवर्सिबल डिसीजंस हैं, दे हैव टू बी परफेक्ट इन द फर्स्ट प्लेस। फौज में अलग अलग किस्म के मिशन होते हैं। एक होता है सिंगल स्टैंड अलोन मिशन, दूसरे होते हैं सीक्वेंशियल मिशन, कि एक मिशन सक्सेसफुल हुआ, उसकी सक्सेस के ऊपर नेक्स्ट मिशन लॉन्च होगी। इसी तरह से ही जब घर बनाते हैं तो इट्स अ सीक्वेंशियल मिशनिंग, कि जो पहला मिशन तो है कि आपने घर बना दिया, लेकिन आगे का मिशन है कि ये घर जो है अगले 15, 20, 50 साल तक जिसके लिए बनाया गया है उसमें इस्तेमाल
So we have three axes, x, y, z, Cartesian axis, and we are placing two extreme points. So this is north pole, this is south pole. We are taking two extreme points. So this is extreme for whole northern hemisphere. So this is extreme point for whole southern hemisphere. Now what we are doing, we are physically mapping our quantum state to binary data. So what is our binary data? 0 or 1. Okay. So we are mapping state 0 for binary 0, and we are mapping in north pole. And we are mapping in state 1 in south pole. So these are our binary values.
So any specific reason to map 0 or not?
Nothing, sir, you can reverse. So conventionally we are calling north pole in above the Arctic, okay, south pole in Antarctic. Can we reverse this direction? Is anything going to about to change if we call the north pole as the south and south pole as the north? No. Just for our naming convention, that's all, for our reference point. If you go extreme north, if you are in north pole, if you are asking what is the north direction, what do you see? You already reached the north pole. If you are asking what is the north direction, meaningless. Same way, if you go for extreme south pole, if you are in south pole, if you are asking what is the direction to south, doesn't make a sense. So in between it have meaning. But once you collapse, you don't have these possibilities. Okay. Then what we are doing, we are associating these two quantum states are called pure states. So if you are preparing any qubit, you have only two chances. Either you can create in state 0, either you are creating in state 1. So these are known states to you. So what we are doing, we are converting our binary data in quantum state. So these are our known values. You are taking a arbitrary point, this green dot. So imagine electron is existing over here. Okay, so this is arbitrary position, randomly it will appear. So you are generating a vector from origin. So this navy blue color vector is called quantum state vector. So this will give information about your quantum particle, where it is located. Okay, so this position is called mixed state. This position is called mixed state because it is in between 0 and 1. In between 0 and 1. Now you slice the sphere, it will create x dash y dash plane, axillary plane. Okay, so from this point, what you are doing a projection to xy plane. Are you able to see this yellow line? Okay, so you are doing a projection from this point to xy plane, it will do intersection. Okay, so it will do intersection. From this point, you are generating a projection towards origin. Now you have two projections. Out of two projections, you are able to make a right angle triangle. Once you got right angle triangle, you are able to apply trigonometry. So we are doing all this stuff to create into a right angle triangle. So once you have right angle triangle, you can apply trigonometry, you will get angles. So we got first angle between z axis to quantum state vector. So this is called theta. Okay, and simultaneously you will get one more angle psi between your x axis to downside projection. So we got two angles out of a Cartesian coordinate. So this point, how will you represent? X comma y comma z. Okay, you can able to convert this Cartesian coordinate into polar form. So that is our objective. So polar form is natural way to represent anything. Polar form is natural way. So remember this. So theta is angle between your z axis to your quantum state vector. If this theta becomes 0, what happens? If theta becomes 0, what happens? It will be in z axis, exactly. So this is the example. So note down this equation. So example, theta equal to 0. So we already covered this equation. This is wave equation. So this is wave equation. So psi equal to cos theta by 2 multiplied with stage 0 plus e to the power I, because it is complex number, it involved with second angle psi sin theta by 2 multiplied with state 1. So superposition is linear combination. So it is linear combination. We are adding stage 0 plus state 1. So this is component for stage 0. This is component for state 1. Why we associated cos to 0, sin to 1? Why we associated cos to 0, sin to 1?
Sin 0 is
Okay.
cos 0 is 1.
Fine, sir. Cos 0 is 1, sin 0 is?
0.
These are opposite components. If you want to represent opposite components, you can choose sin and cos. Sin and cos are opposite. So that is why we selected sin and cos. So if theta 0 is white, 1 will be black. So we are associating sin and cos. So apply this value, what you will get? 1 for which one?
Cos 0.
Cos 0 by 2. Cos 0 by 2. 1 into stage 0, you will get stage 0. So sin 0 by 2, you will get 0. 0 into state 1, this term is eliminated. So you will get stage 0. It means if you apply theta equal to 0 for your quantum particle, it will remain in the same position. It is equal to identity gate. So it will do no operation. So quantum state will remain as it is. So note down. So if you want to retain like a pause button, you can apply theta equal to 0. So second example, if you apply theta equal to pi. So theta is angle between your z-axis to quantum state vector. 0 means pointing to north pole, pi means you need to apply. So if you apply pi by 2, the first component becomes 0, the second component becomes 1. 1 into state 1, you will get state 1. So this is mathematical representation. If you want to see visually, so this is a NOT gate operation. If you apply theta equal to pi, it will move from state 0 to state 1. From state 1, again if you are applying theta equal to pi, it will move back to state 0. So this is an example for NOT gate. So these two are known to us, identity gate and NOT gate. It is classical concept. The next one is pi by 2. If you apply theta equal to pi by 2, what will happen?
It will be along the z-axis.
Z-axis?
No, it will be at exactly 45 degree.
45 degree. Very good, sir.
Cos pi by 4 is 1 by 2.
So it will create equal superposition. So pi by 2 means half of the NOT operation. Only half the sphere, half of the sphere. So it will go to equator. It will go to any place in the equator. For reference, we are marking in x-axis. So this is an example for Hadamard gate operation. So if you apply Hadamard gate, what it will do? It will create equal superposition. So because it is positive state, that is why the sign is positive. If you apply from 1, it will go to negative. Negative means this sign become minus. That's all, the difference. So you have two possibility for Hadamard gate, either positive state or negative state. Okay. Next what we are doing, we are modifying the second angle, psi equal to pi by 2. So if you are modifying second angle pi by 2, it will involve with your complex number. If complex number is involved, it will go for y-axis. So recall the previous session, So this is equal to S gate. Are you able to recall S gate? So from x axis, if you apply S gate, it will move xy plane direction about pi by 2 rotation. So it will move to y axis because it involved with second angle pi by 2. So that is why the imaginary component came for 1. So we covered z-axis. Z-axis contains state 0, state 1. X-axis contains positive state, negative state. Y-axis contains positive y and negative y. So we have 3 pairs. So if you have 3 pairs, you can represent any point in your sphere. If your electron go anywhere in your sphere, with the help of 3 pairs, you are able to locate, you are able to represent. Now we will discuss mathematically. Okay, so state 0 we mapped in North Pole, Northern Hemisphere. Okay, so this is the physical meaning of state 0. So where we map state 0? Northern Hemisphere. So this is Northern Hemisphere, this is Southern Hemisphere. So where state 0 exists? Northern Hemisphere, that is why 1 over there. So state 1 is nothing related to state 0, that is why the lower component is 0. So if you feel mathematics is difficult, if you are understanding through quantum, it becomes much more easier for you. So we use mathematics for real quantities. We are mapping real quantities. What could be for state 1? 0, 1. Exactly. 0, 1. What could be for positive state? For 0, 1, 0. For 1, 0, 1. For plus, which one is 0, ma'am? See, for stage 0, state 1 is doing nothing, no relationship. For state 1, stage 0 is having no relationship. But for positive,
1, 0, 0 plus 1. You need to combine.
You have combined state of both state 0 and state 1. You have relationship. So that is why both components are 1. It is related to both state 0 and state 1. But what is the ratio disconnecting? 1 over root 2. Okay. For negative state, how will you represent negative state?
1 minus 1.
Minus 1. It is not visible. I tried to zoom. Now also not visible. Okay, here minus 1. Here minus 1. Minus 1 means it depicts opposite direction of this sphere. Opposite direction, that's all. So always negative sign related to state 1. Recall, always negative state apply for state 1, not related to state 0. So for I, y-axis, the second component become I. So wherever you are involving in state 1, the negative component will get involved. Okay, for negative y, you will have negative y. So the second component become negative y. So once you understand the physical structure, you can construct mathematical structure according to that. So this is the holistic view of your Q sphere or block sphere. So you can visualize in mathematical way in such a way. So go to this, suppose if you have laptop you can work, otherwise you just observe. So we'll recall state 0, state 1 are pure states, Okay, now we are in pure state, state 0. Once you apply X gate, it will go to state 1. Downside you can see phase equal to 0. Okay, normal, not operation. From state 1, if you apply X gate, it will go back to state 0. From state 1, again if you are applying X gate, it will go back to state 0. From state 0, if you implement Y gate, it will go to state 1 exactly like X gate. But downside you can see the difference pi by 2. So it contains more additional capacity. So it will do bit flip, also phase flip. What is the value? Pi by 2. So from state 1, again if you apply Y gate, it will go back to stage 0. Again it will go back to stage 0. Okay. From stage 0, if you apply Z gate, nothing happens, identity gate. Okay. So click state 1, apply Z gate, you can notice phase flip pi rotations. So Z gate, it will introduce positive to negative, negative to positive. So click 0, click Hadamard, so it will come to positive. From 0, if you apply Hadamard, it will come to positive. From 1, if you apply Hadamard, it will go back to negative. Okay, now we are in positive. If you apply Hadamard, it will go back to stage 0. So you can write in this way. So from stage 0, if you apply NOT gate, it will go back to state 1. From state 1, if you apply NOT gate, it will go back to stage 0. Okay. From Y, if you apply stage 0, okay, it will go back to state 1 plus pi by 2 phase shift. So from this state, again if you apply Y gate, it will go back to stage 0. Okay. So if you apply Z gate in stage 0, it will go to stage 0. It will retain in stage 0. Otherwise you can draw in this way. It will retain in stage 0. From state 1, if you apply Z gate, it will go to negative state 1. From negative state 1, if you apply Z gate, it will go back to state 1. Okay. So from stage 0, if you apply Hadamard, it will go to positive state. From positive state, if you are implementing Hadamard, it will go back to stage 0. From state 1, if you implement Hadamard gate, it will go to negative state. From negative, if you are implementing Hadamard, it will go back to state 1. So just note down all these descriptions. Ma'am?
A small felicitation is there for principal by somebody.
Okay.
Can we take a break of 2 minutes?
No issue. No issue. So we'll take 2 minutes break. Very fine, sir. They are asking, interacting. Okay.
I got very good feedback. They are impressed by
Okay.
Can you just switch off for a while? Only projector you switch off.
Switch off.
Okay.
Good afternoon, everyone.
So now we are in stage 0. Now we are in stage 0. If you apply Hadamard, it will go to state plus. From state plus, if you are applying S gate, it will go to state I, not Y. So Y is axis. So positive Y means state I, negative Y means state minus I. From I, if you are applying S gate, again it will go to minus state. So we will achieve the same state from positive to minus by doing with Z gate. So from state 0, if you apply Hadamard, it will go to positive state. From positive, if you apply Z gate, it will go to state minus. Now compare this and compare this. Try to get some inference.
Outcome both are same.
Both are same.
We take most and we take one side.
Yeah. What is the correlation? Which one, ma'am? Okay. So both are same. What we can conclude? Okay, time is less. 2s equal to 1z. Okay, so 2s equal to 1z. Same way, if you have Hadamard gate, apply over stage 0, it will go to positive. From positive, if you apply T gate, it will go to in between positive state and I state, in between. If you apply one more T gate over here, it will go to I state. So 2 T gate equal to 1 S gate. Able to get the idea, right? So you can formulate. So 2 T equal to 1 S. So 1 Z equal to 2 S equal to 4 T. So you can find the relationship in this way. Suppose if you are implementing 4 T gate, you can minimize within 1 Z gate. If you need to step down, you can choose the proper gates. Suppose if you want to shorten, you can choose the less number of gates. If you want to elongate, you can choose the minor gates. So that is the idea. Okay.
Can you please give the example with respect to the space navigation?
Space navigation. Take an example of moving a robotic arm, ma'am. So if you want to move the robotic arm in a single shot, you can use Z, opposite direction. But if you want to do half of the way, you can use S. So if you want to finitely control in middle of them, you can use T. So this is one single example. So moving robotic arm. So now we are in stage 0. Now we are selecting RX. RX means rotational NOT gate. So NOT gate, what it will do? It will rotate from 0 to state 1 directly. So instead of doing that, we can break step by step NOT operation. So NOT operation also able to break down. So I am clicking RX. So here deta is pi by 8. Now visible? Deta equal to pi by 8. So I am giving the minute rotation for NOT gate operation. So from 0, I am clicking RX 1, 2, 3, 4, 5, 6, 7, 8. So 8 times I need to apply NOT gate to reach state 1. Imagine how finitely you can implement NOT gate. Slowly, right? So instead of opening your tab, you are having a control. So finitely you are able to control. So next to it, you have deta equal to pi by 12. It means the same NOT operation you can reach with 12 steps, like a slow motion video. So if you have a slow motion video, you can view each and everything in detail. You won't miss anything. So this is an example. You can go for deta by 100 also, deta by 1000 also. So imagine how slowly you are able to process, or how finely you are able to process. Whatever the gates we discussed, we are able to create quantum circuit for that. For that, you go for IBM quantum platform. You just note it down. Okay. So they will share this video. So watch that video. Do in your laptop at your free time. If you don't have laptop, don't worry. You can do at your home after receiving this video. So click IBM quantum platform. You can reach composer. So downside you can reach composer. I will zoom for you. So under the learning tab, under the learning, so you have composer option. If you click this composer, it will appear like a musical notes. It will appear like a musical notes. So this will appear in this way. Q0, Q1, Q2, Q3. Actually you can see lines over here. Electrical lines. It is not visible. Maybe I will change theme. Let me check. Whether lines are visible now? Visible, right? Okay. For simplicity, for understanding purpose, we are keeping only one quantum bit. So Q stands for quantum, C stands for classical. So I am clicking Q0, selecting bin button, Q0, bin button, Q0, bin button. So only one quantum bit, 4 classical bits. So how many quantum bits you have? Equally you need to maintain classical bits. So that is your basic thumb rule. So it is not mandatory, but if you are maintaining, it will be easy for you. So we have one quantum bit, we have one classical bit, right? So you can see output window, this is for probability. So we have two options, outcome 0, 1, okay? Because the qubit is initialized to state 0 by default in IBM. It is pointing to North Pole. North Pole means it is pointing to state 0. So full probability come for state 0. So this is the percentage of probability, 100% probability to get value 0. This is what it means. So look at the Q sphere. Look at the Q sphere. It is pointing to North Pole. If you place your mouse over there, you can see details. If you place mouse over there, you can see the details. What is the state? State 0. What is the probability? 1 means 100% will get value 0 if you do measurement right now. So right side, you have coding part. So this is open Quasim. Quasim means quantum assembly language. Okay. So this is platform independent. So if you got this quantum assembly code, you can convert into Google platform, you can convert into Microsoft or Amazon. Suppose you create a quantum circuit in IBM, you can be able to convert into any platform. Okay, so this is one coding part. So if you select over here, you can select Qiskit Python version. So this is the Python code for this circuit. Now look at this code. Line number 1, from Qiskit import quantum register, classical register, quantum circuit. We are importing 2 modules from a library package, Qiskit. Okay. Next what we are doing, we are importing pi value from this library, NumPy. So line number 4, what we are doing, we are creating quantum register. How many counts? 1. What is the label for it? Q. Okay, we are creating a variable Q register underscore Q. So line number 5, what we are doing, we are creating classical register. What is the count? 1. Label C. Okay, what is the variable? C register C underscore C. So line number 6, we are creating a quantum circuit. This is a function call. So quantum circuit is a function call. For this we are passing 2 parameters. What are the parameters we are passing? Number of qubits, number of classical bits. So here it will substitute 1, 1. This is what the meaning. Okay. What is your circuit name? Circuit name is circuit. Your circuit name is circuit. So this is your circuit. This is your circuit. Always in IBM, it will start from stage 0. In IBM, always start with stage 0. It means you are starting with state 0. Now move your mouse over here. Move your mouse over here. You can see quick output. So this is called phase disk. So right side in your circuit you can see phase disk. Okay. So here you can see quick information about your quantum state. Okay. So what is the phase? 0. What is the real part? 0. What is imaginary part? 0. What is the probability of getting state 1? 0%. Because it is started from stage 0.
What is that last one, sir? Purity of reduced state.
Purity of reduced state is 1 because it is pure state. Stage 0 is pure state. State 1 is also pure state. Now what do you do? This is your NOT gate. Second gate is your NOT gate, cross wire. If you drag and drop in Q0, it means we are implementing NOT gate in quantum bit 0. It means starting with stage 0. From stage 0, if you are implementing NOT gate, you will get state 1.
We drag and drop, it's not happening. What should be done?
It will happen, sir. Click it. Click it. Just drag and drop.
On the line, no?
That's on the line. So we are starting with stage 0. Okay, stage 0 represents off state. Okay, this is your NOT gate. So what NOT gate will do? It will do bit flip or state flip. So now it is become state 1. State 1 means it is on state. So on state means power supply will happen. Imagine power supply will happen. So that is why you got different output over here. You got the blue color disc. Blue color disc. Now place mouse over here. Now place mouse over here. Now you can see phase 0, real part 0, imaginary part 0. But what is the probability of state 1? 100%. If you do measurement right now, we'll get binary value 1 for 100% for sure. So how to do measurement? So you can see in third row, fourth gate, like a gauge, drag and drop. So this is called measurement gate. This is called measurement gate. Measurement will happen in z-axis. Measurement will happen in z-axis. So in z-axis, what we map? State 0 or state 1. It means either you will get binary value 0 or binary value 1. Okay. Now what you will get? State 0, NOT gate, state 1. State 1, if you do measurement, what you will get? Binary value 1. We are starting with state 0. We have NOT gate. After this, it will change to state 1. From state 1, if you are doing measurement, you will get binary value 1. Look at your probability. Look at your probability. It is pointing to 1. What is the percentage? 100%.
That C value is not showing. What is that? 0?
Which one, sir?
So in the 0 it is showing 0 point.
No. It is not meaning of that 0, sir. Maybe I will add one more qubit. I will add one more qubit. I will do measurement. Okay. So measurement Q0 to C0. They mentioned that one.
Classical 1 lab 0 how is not showing anything. Okay, sure.
Now I changed. See, so this measurement we are doing from Q0 to C0 technically. So that is why I mentioned 0. So this measurement we are doing from Q1 to C2. So that is why showing 1. So this is not your result. It is the relationship between your quantum bit and classical bit. So if you have doubt, what you can do, you can click a gate, you can click edit button, then you can see. So what is your qubit? Q0. What is your C bit? C0. So we will stick to single qubit. We will stick to single qubit. So go to view, go to view, go to panels, enable state vector, enable state vector. So we have three outputs. So one is probability, one is state vector, one is Q sphere. So in state vector, you will have full signal strength for stage 0. So empty circuit, we have full signal strength for stage 0. Okay. So probability, you have 100% probability for stage 0. So what I am doing, I am dragging and dropping a NOT gate. Now everything is changed. So if you implement NOT gate, what happens? The probability turned for 1, 100%. The state vector amplitude turned for 1 for full signal strength. So full signal strength means 1.0. So amplitude equal to 1. 1 means full signal strength. So if you implementing one more NOT gate, what happens? So we are starting from stage 0. Stage 0 NOT gate becomes stage 1 in between. So from stage 1 again NOT gate will turn into stage 0. Now it will show only for 0. Are you able to get the idea? Okay. So what you can do, you can click this inspect button. Okay, you can inspect layer by layer. You can inspect layer by layer. Okay. Now we are starting from stage 0. I hope you are able to understand now. So it is like a play button. You can move forward step by step, or you can go for last step.
Initially, two things are being shown, properties and Q sphere. If you want to add a state vector also, what should you do?
State vector, which one, sir? Here. You cannot add, you just able to visualize. State vector, go to view, go to panels, go to view, go to panels. You can enable, disable all these views. Okay, sir. So we are starting from stage 0. We are implementing NOT gate, shifted to state 1. Again we are clicking the next step. One more time we are implementing NOT gate, again came back to stage 0. So if your circuit have 50 gate operation, we can able to understand layer by layer by using inspect. During inspect, you cannot change your circuit. You cannot able to edit. Okay. If you want to edit, disable inspect, then try to edit. So some point of time, we forget why it is not working, because you enable inspect.
Here we are actually using the quantum computer.
Here we are doing simulator, not quantum computer, but we can able to execute this circuit using quantum computer. Once you have credit card, once you created login, they will give quantum computer access for you. So I'll show. So go to here, click compute resources. Go to that menu, select compute resources. You can see how many quantum systems are there. If it is locked, you are not able to access. Okay. If it is free, you are able to access. For me, I am able to access 3 quantum systems. So IBM FES, IBM Marrakesh, IBM Torino. So this is the capacity, 156 qubit, 156 qubit, 133 qubit. So apart from this, these 2 are under maintenance. This is available right now. So we need to check the pending jobs. Which one have least pending job, we need to select that system. So this contains 11,645 pending jobs. So I need to avoid this system. So these are the processor name, and these are the error measurement parameter, all this stuff. So if you don't have credit card, you cannot access real hardware. So whatever I design over there, I am able to execute in real quantum system.
Now, since we are logging, it will be available for 30 days, showing 29 days.
A trial, sir. Trial. You used your credit card?
No, I never used anything.
Okay.
Just by logging on.
Trial means 30 days. 30 days.
After it is going to charge.
I don't know, sir, whether they will charge you right now. Because if you are not giving any information, they cannot charge. How they will charge?
Sir, suppose I used it earlier. After 30 days expiry, they will charge it. And the charges will be like 4,500 or something like higher than usually. And stop working after that. I can't spend for, they're charging only for 1 day, half an hour, they're spending 5,000.
Sir, 1 minute, they will charge 9,000 rupees.
So the charges are delayed. So after that, stop.
Don't worry, sir. In Amaravati, they purchased IBM quantum system. They will give free of charge. They will open, sir. They will open call. You can apply. For researchers, they will give free access. Because the maintenance costs that much. Initially, they try to grab people. Once they got people, they try to charge. So all MNC will do like this.
So how to know which system we are using, sir? Among that?
Here we can see, sir. Setup and run. If you click setup and run, you can select your systems. So top right, you can see setup and run. So if you click that, you can select your quantum processor unit. Okay. So next what you do, drag and drop I gate, drag and drop I gate, identity gate, it will do nothing. So stage 0 retained as stage 0. So if you implement n number of I gates, it will do nothing. It will be same. It will be same. Identity. So next, try to implement S gate. Sorry, try to implement Z gate. Observe what happens. Q0, we are starting from stage 0. We implemented Z gate. Recall Z gate. Phase change, we are starting from stage 0. Stage 0, if you are implementing Z gate, nothing. It will act like identity. So no changes. To visualize Z gate, we are supposed to add NOT gate before that. So to visualize Z gate, we need to add NOT gate before that. So once you add NOT gate, what happens? It will change to 1, but look at the color combination. So this is your color wheel. This is your color wheel. So 0 means navy blue color. Okay. So pink means pi by 2. Red means pi. Okay. This yellow means pi by 3. So if it is showing in red color, it means I applied pi rotations. It means from 0, stage 0, NOT gate, state 1, from state 1 Z gate minus state 1. Pi rotations. So from positive to negative side. So that is why showed in red color. Here ma'am, state 1 only, but the color changed to red. If I delete this Z gate, you can see the difference. State 1 only, but in 0 rotation, 0 phase angle. Okay, now we implement S gate. Now we implement S gate. So what S gate will do? What S gate will do? It will create pi by 2 rotation, phase shift. That is why the angle come from here, pi by 2. So if you implement T gate, again one more T gate, you will have the same effect of one Z gate. So one S gate combination with 2 T gate equal to 1 Z gate. So everything will operate in state 1, not in state 0. So S gate, T gate, Z gate are phase gates. So phase gate will not operate in state 0, it will operate from any states. Apart from state 0, it will operate from any states. So I'll delete all this stuff. Visible ma'am, visible. Now drag and drop Hadamard gate, the first gate. Now you can see the difference. So far we only discussed classical phenomena. So implement Hadamard gate from stage 0. We implemented Hadamard, it will go to positive state. It means sometimes it will create stage 0, sometimes it will create state 1. Randomly it will create. If you do measurement, it will collapse. So look at here, at the same time it is pointing to north pole, also south pole. Equal superposition. Okay, so look at the amplitude. Look at the amplitude. Place your mouse over here. You can see 0.707. It means 1 over root 2. So if you take modulus, if you do square, you will get 0.5. So during superposition only, you are able to difference between state vector and probabilities. So if you take modulus for amplitude, do square, you will get probability. You notice that formula, right? So if you take modulus for your amplitude, if you do square, you will get probability. So that is why here 0.707, here 0.5. Q sphere, it is pointing both north pole and south pole, sir. Superposition. Moves over. Okay, I will move.
In our case, it is showing 0.5 and 0.5.
Yes, sir, exactly. It is not equally superposition. Okay, little variation will be the randomness. See, if it is exactly 50-50, you cannot take any decision, right? Sometimes it will add little randomness, little biased. So each time these values vary, sir. Each time these values vary. So this is simulator. This is created by program. If you go real hardware, these values will change. Okay. So after Hadamard, if you do measurement, what happens? After Hadamard, if you do measurement, what happens? Superposition state will get collapse, we'll get only one possible outcome. So here we got 0, sometimes we'll get 1, okay, sometimes we'll get 0, randomly we'll get value.
Sir.
Yes, sir.
One query over here. So, I'm just looking in the optimization part. So, the optimization, we have got some of the standard equations are there. ATME equation and x square plus y square. Can we implement those equations?
Definitely, sir.
So, can you just show me how we implement one simple algebraic equation?
Okay. Go to learning, go to view all courses. This is what you are asking, sir. Optimization, barren plateaus.
No, I'm just let me be more precise regarding the optimization. We have got the meta-heuristic algorithms are there.
Okay.
There will be some standard equations.
HHL.
Not HHL. Just give me a just
Okay.
How to get the bill?
Which one, sir? Go to here, learning tab, view all courses. You can select any course. So for this, what I did, I went for variational algorithm design. So here they have optimization loops.
So if you are using the simulation part, again we are depending on the backend hardware, what we have to do.
So simulation is more than enough to complete a PhD.
So whatever the simulation you are creating in Python, it indirectly represents the hardware that is present in your system, right?
Yes, yes. Using our system.
Using your
System.
Then what is the purpose of going towards this platform?
Understanding purpose, sir.
No, sir. Understanding purpose is this. In Python also I can import the same libraries, whatever you have.
Very good. Very good.
The same thing I can use it. Why should I
Take an example of Hadamard gate. If you are implementing using simulator, the same value you will get. For an example, if you are implementing NOT gate, what is the expected output? 1. Okay, but if I am running in actual quantum computer, what you will get? Let's try. Sometimes it will run very quickly, sometimes it will get delay. Sometimes we need to wait for 1 hour, 2 hour, half day. It will take some time. Completed. God grace. Look at here, sir. So I got result as 1 for 890 times. I got 0 as a result for 134 times. In simulator, you cannot get this result. If you are able to get, you will get the same pattern. But if you are executing in real system, the results will differ. So that is the difference. At some point of time, simulator will not help you. To understanding purpose, we can use simulator.
Similarly, how many iterations are being running?
You can set up, sir. You can set up, if you count 134 plus 890, you can count. So you can increase to 5,000 times, you can increase to 10,000 times. It depends upon your application. How many times you need to iterate? It depends upon your algorithm also. Some algorithm you are running for single time, you will get the correct output. Take an example of Groover's algorithm, not Groover's. Josh algorithm, you are able to execute within a single iteration, you will get the result. So Groover's you need to run for root 10 times. So likewise it differs, sir. Okay, we explored Hadamard. Now we will discuss control NOT gate.
So the machine that we are trying to use, it says it is 156 qubits. The maximum number of qubits I can use is 156.
You can use.
156. And similarly, the running time, whether it is dependent on the qubits or the algorithm.
Algorithm, sir.
Algorithm what we are trying to
And also depends upon qubit also. If you have more number of qubits, it will execute faster way. But in our code, what we did, we used only 1 qubit. So remaining 155 qubits are ideal.
And one more thing, whenever we are using more than 1 qubit, whether the qubits should be dependent or independent.
If you are creating entanglement, it is dependent. If you are not creating entanglement, independent. I am talking about entanglement, how to create entanglement I am talking. So control NOT gate is used for creating entanglement. Okay. So I am looking proper slide. Yes. So this is control NOT gate. You can note down. Control NOT gate is called CNOT gate. So CNOT is expansion of control NOT. So you're able to control your NOT operation. This is what it means. Okay. So this will act on 2 qubits. If you want to create entanglement, at least you need 2 qubits. So CNOT gate is 2 qubit gate. So far we discussed only single qubit. Now we are moving for 2 qubit gates. Okay. So it will flip the second qubit if the first qubit is 1. It means you have 2 qubits, Q1 and Q2, and the Q1 will act like control, the Q2 will act like target. Imagine if you have light over here in Q2. For this light you have power supply in Q1. So this is your switch. If there is a power supply, then only this NOT gate will perform. This light will get on. So this is your switch. This is your device. Imagine in such a way. So after going through control NOT gate, the states will get changed. Q1 dash and Q2 dash. So Q1 is your control, Q2 is your target. Q1 is 0 means there is no power supply. No power supply means power supply will not come down. So it is like soldering. Okay, you are bringing connection from here to here. So no power supply will come. This NOT gate become inactive. So NOT gate become inactive means what is the state of Q2? 0. So 0 will retain as it is. So this is what it means. So if Q1 is 0, Q2 will retain as it is. So next, if Q1 is 0, Q2 is 1. It means here there is no power supply. But here we are implementing a NOT gate. NOT gate means it will go for state 1. State 1, inactive NOT gate, state 1 will retain as it is. So that is why we got 0 1 state, combined form. Are you able to understand first two steps? Okay. The third one, Q1 is 1, Q2 is 0. It means we implemented NOT gate over here. It means power supply will be there. It will come down. It will enable this NOT gate. So whatever the state in Q2, it is bit flipped. So look at here. Q1 is 1. What is the state of Q2? 0. So this is get negotiated. So I got 1 1. So next example, Q1 is 1, Q2 is 1. Because Q1 is 1, Q2 is negotiated. 1 0. All of you have built on the screen.
CNOT should be shown with two data. Two data bits. CNOT should be shown with 2 bits.
Two combined states. So I can put like this. So 0 0 state. Like this.
Here, how entanglement is occurred, sir?
It will create a relationship. Whatever happens for first quantum particle, it is able to implement the second quantum particle. So something is happening over here. Then the particle 2 is get affected. Are you able to get, ma'am? Q1 is 1. Because control is present in Q1, Q2 is negotiated. So this is an example for entanglement. I will come. If you understand control knot, we will create entanglement. All of you able to understand control knot? Now what do you do? Click Q0, click plus. We are adding one more qubit, sorry. So click Q0, click plus. You are adding 2 qubits. Click C1, click plus. You are adding 2 classical bits. So qubit you can view individually. Classical bits you need to view combined view, double line. So 100 classical bits are there. It's shown in only double line. But qubit you are able to visualize individually. One minor difference. Okay. So what do you do? Drag and drop NOT gate for Q0. Now the state is changed from 0 0 to 0 1. Are you able to do? Initially you have 2 qubits. 2 qubit means 0 0 states. So implement NOT gate in Q0, you will get 0 1 state. Drag and drop this NOT gate to Q1. Now it is moved to 1 0 state. Okay. Implement one more NOT gate. You have 1 1 state. Now you explore 4 states. So how to create 4 states you are able to use with your NOT gate. Okay. Now empty your circuit, clean your circuit. Drag and drop Hadamard in Q0. Observe what happens. Drag and drop Hadamard gate in Q0. Observe what happens. So Q1 have the probability of state 0, state 1 because it is half 50-50 chance. So 2 possibilities are there for Q0. What is the possibility of Q1? always stage 0. Always stage 0. So the Q1 is mapped to rightmost bit. So note down this point. So Q0 is mapped to rightmost bit. 0, 1 means it is pointing to 1. So Q1 is mapped to leftmost bit. 0. They map reversely. Okay, so there are two possibilities. So stage 0 is possible, state 1 is possible. For Q1, always stage 0 is possible. Okay, so take first example 0, 0. Take first example 0, 0. So this 0 is possible by Q0, this 0 is possible by Q1. So that is why this combination is enabled. Able to get the idea? Okay. So next what we are doing, we are taking 0, 1. We are taking we are taking 0, 1. So this one is possible by Q0, this 0 is possible by Q1. So that is why the second combination is enabled. So look at the third combination. What is the third combination? 1, 0. Okay. This 0 is possible by Q0. This one is impossible by Q1. So that is why these two combinations are impossible for this circuit. Able to follow? Right. Now drag and drop the Sadamat to Q1. Now drag and drop the Sadamat to Q1. You can see the different combination. You will get 0, 0, 1, 0. Yes, ma'am.
So every time we have to give a 0 state as an initial state for every
You no need to give, ma'am. By default, it will create from stage 0. By default. If you want to change one, you need to implement NOT gate. That's all. So, implement Hadamard gate for both qubits. Implement Hadamard gate for both qubits. Enable all possible states simultaneously. Enable 0, 0, 0, 1, 1, 0, 1, 1 simultaneously. So, what is the amplitude for all these states? 0.5. What is the probability for this state? 0.25. Are you able to get the idea? If you take modulus, if you do square, you will get probability. Now I am deleting the second Hadamard gate. I am implementing control NOT gate. So do like this and observe what happens. I'll zoom.
So here Hadamard gate should be 1, 1, 1 minus 1 or 1, 1, 1.
We are starting from 0, Q0 starting from 0 state. After implementing, either create state 1, we don't know what is the state. If output of Hadamard is state 0, no power supply. No power supply means it will not come down. This NOT gate is inactive. So what is the state before this? State 0. So state 0 will retain as it is. So here state 0, here also state 0.
We are implementing 2 qubits.
Okay.
We are giving for a Hadamard gate 2 qubits.
Okay.
So then the matrix should be 1, 1, 1 minus 1. So here we are considering 1 qubit.
Only 1 qubit.
With Hadamard.
Huh.
It should be 1, 1. Then we are passing So how do I implement that case here? For 2 qubits, I have a gate. So whether I place it in between, is it possible?
You are asking one more qubit or?
No, one Hadamard gate and the
We cannot do, sir.
we cannot do that.
See, Hadamard gate, we try to create superposition. For one kind, if you are simply tossing, superposition is get created. That is the idea. So only one input for Hadamard gate. One qubit, if you implement Hadamard gate, it will create equal superposition. It is not like but output of Hadamard gate, you have two fins. Either it will create 0, either it will create 1, but randomly it will happen. No, sir. So, after implementing Hadamard gate, if you implement not control NOT gate, what happens? Suppose if Hadamard gate produce state 0, no power supply will not come down, NOT gate is inactive. So here state 0, here also state 0, so 0, 0 will get. Suppose if output of Hadamard is state 1, power supply will be there, it will come down, it will enable NOT gate. So previously state 0, now change into state 1. So here also state 1, here also state 1. So whatever happens for first quantum particle, it will impact in the same way for second quantum particle. 0 means downside also 0. Okay, 1 means downside also 1. So this is positive correlation. Or if you go down, ma'am, if you go down, you can see. So here it is state 0, 0, state 1, 1. So we have 4 states, right? 0, 0, 0, 1, 1, 0, 1, 1. Okay, you enable this inspect. Enable this inspect. So initially what is this state? 0, 0. Okay, so after Hadamard what happens? After Hadamard what happens? Only 2 possible combinations. 0, 0, 0, 1. After control NOT, you will get the same impact. 0, 0, 1, 1. So what do you do? After going to home, do one by one. Single qubit, okay, drag and drop single gate, observe what is happening in all windows. Do step by step, multiple possibility, then only able to understand. Always start with a simple gate. So what sir is asking is about optimization. It will go beyond 100 gates. We cannot understand how to implement in quantum. Ma'am, I will delete this. I will delete this. So we starting from stage 0. Stage 0, Hadamard. What is the output combination? Either 0 or 1. For single qubit, we have 2 combinations. 2 combinations. So here Q1, what is the possible state? Always state 0. Okay. So 1 combination multiplied with 2 combination, you have only 2 possible combination. Either 0, 0 or 0, 1. Because this is always 0. You got this, man? Okay. You try to understand one by one gate. You try to understand one by one gate. Now look at this. State 0, 0. We implemented NOT gate, control NOT gate. What is the output? 0, 0. Because no power supply. No power supply means whatever the state over here, it will retain as it is. So try to compare with that CNOT logic table. If you do so, you can be able to understand. This is a tensor. Yes, tensor. Okay, so what I do, if I implement Z gate over here, so Hadamard gate followed by control NOT followed by Z gate, what I will get? You can look at the color difference, you can identify 0, 0, 1, 1, but we can find phase change. We can find phase change. Red color you can see. So instead of state 1, 1, sometimes you will get -1 also because of this Z gate. So this is one difference of entanglement. One difference of entanglement. Okay. So next what I will do, I will implement NOT gate over here. I will zoom it. So look at the output. Hadamard gate followed by control NOT. In second qubit we implemented NOT gate. What is the output we got? 0, 1, 1, 0. So previously what we discovered, 0 means downside also 0. Okay, first qubit is 1 means second qubit also 1. Positive correlation. What about this? First qubit is 0 means the second qubit is 1. Opposite to each other. This is opposite correlation. So the first example is like friends, they will support each other. Okay, the second example is like enemies. They will always blame, they will behave opposite. Okay, so if we implement a Z gate over here, if you implement Z gate over here, then you have difference. So instead of opposite state, you have phase difference also. So for this 4 variation, they awarded Nobel Prize. So this is an example for Bell states. So Einstein rejected this theory. So John Bell professor, he demonstrated this Bell state experiment. Very simple experiment. For this experiment, they awarded Nobel Prize. So I can demonstrate using a physical apparatus also. Bell states, not bell curves. It is named under that scientist, that's all. That's all, not like Bell. Not like Bell. Which one, ma'am? Bell states. If you refer Bell states in quantum, you will have so many materials. So all these will come under your courses. So go for learning. So within a single course, all these concepts are covered.
Learning which is the first course to start, sir?
Course 1, sir. Course 1, basics of quantum information. So in this course, all this information will come. With Qiskit code also. You can do, you can experiment. Yes, sir, break. We will take 10 minutes. 10 minutes. Switch off, sir.
For the research purpose, how much they will accept if you simulate in
Simulation is more different you will see. You can ask for accident, where the scale is, how it works is. But simulation we can ask for check with your system. Simulation is more than supercomputer.
So this is one institute, Society for Electronic Transaction and Security, located in Chennai. They have collaboration with IIT Madras. They are doing quantum communication. Okay, they have QKD device. They are teaching quantum cryptography. They have physical hardware also. So they are frequently conducting workshop. If you go for 5 days hands-on, definitely you will get lot of detail. Because they are specialized, they are teaching this for past 10 and 15 years. So that is why I recommend. So if you go for MTech, this is IAC MTech page. So students require GATE score. So any branch students can apply for MTech in quantum. Okay. Then this is DIIT Pune. So this is sister concern of DRDO. They are offering MTech in quantum. So all these institutes require MTech in GATE exam score. So this is Indian Institute of Space and Science Technology in Thiruvananthapuram. They are offering MTech in quantum. And this is my social media page in LinkedIn. I keep on posting related to quantum. So if you want to get information, you can follow me or you can give connection request. So have you heard about ETH Zurich? This is the topmost university in Europe. It stands 8th rank in QS ranking. Okay, so they have nearly 19 different quantum research centers. Nowhere in this world you can see this much of resource. They are offering masters in quantum. They are admitting nearly 18 students across the globe. So only one student will get admitted in this university from India. Those students completed engineering physics from IIT Madras and IIT Bombay. They are supposed to work under topmost quantum scientists and professor. These professors need to give recommendation letter. Then only they will consider their application. So if you are applying from normal institute, they won't consider. So they mentioned it should be nation's topmost institute. It should be relevant, otherwise they won't consider. So engineering physics is a separate program. You can browse, only available in IIT and NIT. One private university you can look up in Bennett University in Greater Noida. So likewise, try to explore within India. So much of institutes are there. If you keep on exploring, you will get idea. Go and attend conference workshop, then you will have physical connection. So they will help you. So everybody is having limited knowledge in quantum. Nobody can nobody can claim expert in quantum. So trying to explore quantum is like trying to understand the nature itself. Nobody can master, including all Nobel scientists. Right? We try to explore only little bit. Which one, sir?
Quantum computing, computing. How is the job market?
Job market now only for PhD, but in future it will open for everyone, sir. So more number of people involved in this domain, more interested will be created, more job opportunity will get created. It is like a comparable to India's freedom movement. more people combine together, club together, faster it will happen. India already missed semiconductor opportunity. Now we are missing quantum also. China invested $15 billion, means they have very good semiconductor industry. So based upon that, they will build quantum industry. Just now we are focusing on semiconductor. So any more doubts, any more question, you can reach me out. Yes, ma'am. Qubit by qubit. Qubit cross qubit. If you Google, it will come. Registration they will mention, ma'am. In that website they will mention when they will open, when they will close, everything they will mention. You can contact them also for inquiry. For everyone, sir, across the globe. Why they need to? The program itself for school students, sir. You can apply for teacher, like a teacher. You can connect with your school. You apply behalf of the school like a teacher. Qubit cross qubit, qubit by qubit. So anyway you will get. Okay, thank you all.
Thank you, Dr. Jayakumar, sir, for highly insightful and engaging session on quantum circuits and simulations. Your clear explanation of quantum circuit design and hands-on demonstration using Qiskit and IBM quantum experience were extremely valuable and enriching. The session greatly enhanced our understanding of practical quantum computing and was truly inspiring. Thank you, sir. Now I request Dr. Tabassum Arama to kindly hand over a small token of gratitude.
मैं जा रहा हूँ, सब हो गया, मैं जा रहा हूँ।